Good morning, everyone. How are you today? Good. It's great to see a full room here for the Kelp event. My name is Alan Joseph. I'm the Director of Applied Research here at NSCC. So it's a pleasure to be able to come and kick off a little welcome for the event. I wanted to first acknowledge that we are here in Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq people. I just came back from Unama'ki up in Cape Breton last night, so I'm a little road weary. Also wanted to acknowledge the over 400-year history of African heritage here in Nova Scotia. So today is February 1st, and we're kicking off African Heritage Month here in the province and across the country. So we are going to have a fun-filled day, I see by the agenda, looking at some of the research happening around kelp. And I want to introduce and thank the team behind all of this work. A lot of work happens behind the scenes to make events like this happen. So we have research squads from various jurisdictions. I see some visitors from other provinces in the room. Welcome. And this is one of the first multi-institutional partnerships that we've conducted as a college under some new research programs from our federal funders. And I have to say, it's been a real success so far. It's been a lot of fun. I can tell that people are enjoying the work, and that's going well. So we look forward to seeing much more of this. I'm going to turn it over to Dr. Tim Webster, who leads our Applied Geomatics Research Group here at the Nova Scotia Community College. Tim was recently recognized with the Research Nova Scotia Public Impact Award for his work spanning over, I shouldn't say how long, should I, Tim? Yeah, that's right, a generation or more of excellent work in excellent work in all things coastal, flood risk, and now some great new work in this specific area around the kelp. So I'll turn it over to Dr. Tim Webster, and have a great day, everyone. Thank you.
Thank you, Al. Very much appreciate that, and welcome, everyone. It's nice to see some old friends, and it's nice to see people I don't know. So I'm looking forward to chatting with you at the lunch break. Can we switch the slide over, please? Okay, thanks. So I thought first I'd give just a quick overview of the, as Al mentioned, the grant. So remote sensing technology to improve marine spatial planning, kelp assessment, and aquaculture. So pretty broad topic, and our partners are Canada's Smartest Kitchen out of Holland College, out of Prince Edward Island, and College of the North Atlantic. And we'll be hearing from them a little later, but our colleagues from Canada's Smartest Kitchen are in the back table there, and they've brought some lovely snacks for us. So this was an NSERC funded project. It was called a ARTP, Applied Research Technology Partnership Grant. There were two options. One was to go for a 2-year project where you needed 3 colleges to partner up. So we did that, and we were awarded the grant in 2021, December 1st, but they only awarded us half the money we asked for. So that was a little bit problematic, but eventually when they finished giving out all the other awards, they topped us up to our full amount, which was near $2 million over the lifespan of the project. And, I can't help but have to brag a little bit on this one. We apparently we got feedback that the proposal was ranked #1 in the first round of the grant, and I just took a little excerpt from the review panel there. So we were quite pleased with that, and lots of people went into helping make that possible. So a lot of our work at AGRG, Applied Geomatics Research Group, will focus on, okay, I think, yeah. If this laptop breaks, then I'll just pass in my resignation. Focuses around this technology known as topobathymetric LiDAR. So it's a sensor that's mounted in an aircraft, fires laser pulses at the ground and the water. And the unique thing about it, we've got 2 lasers on board. One is a near-infrared laser for mapping the ground and the water surface, and we have a green laser that will penetrate the water column and give a return off the seabed or other features that are growing on the seabed, like kelp, for example. And this results in a point cloud, and from that we can do all kinds of GIS analysis from that. So this was taken from the proposal, and we had many partners. We're going to hear from Kate Collins a little later on, and our colleagues from Mironov, who also were instrumental in helping out with the project and gave a letter of support from the Nova Scotia Aquaculture Association. This was kind of our planned idea of where we might survey. In reality, we didn't actually accomplish all of those surveys, and what we're going to do today is show you year 1 of that project. Now, I will give a little bit of background of what sort of why we came about writing this proposal. And the first research question was, can topo bathy LiDAR be used to map and quantify kelp? So, and we were interested mostly in the Nova Scotia area and Newfoundland, and we've teamed up with Patrick Gagnon of Memorial University, who is studying kelp over in Newfoundland, and that's been a very useful partnership. Part of the motivation for this study was a project we did with Acadian sea plants down in southwest Nova, where we were looking at seeing about quantifying rockweed, which is an intertidal species. So on the left-hand side here, this is a transect showing a cross-section at high tide, and you can clearly see the 2 bands of points here. One is the top of the rockweed canopy, the next one is the seabed. And we actually flew it at low tide as well. So we were able to map the height of the rockweed quite well, and that was quite encouraging. So this, if you've never sort of seen this stuff, this is what it looks at low tide, but at high tide, it has an air bladder, so is floating up quite nicely, and therefore worked out well. And this shows the cross-section we were just looking at. So this was kind of the emphasis to say, hey, maybe we can go deeper and actually map kelp. We published those results of the rockweed in Botanica Marina back in 2019. The next question is, and we're going to hear from Kate later on and Flora about what the Nova Scotia Aquaculture Association is doing with its members. Many of them are starting to grow kelp. So, how can we help support the shellfish and kelp aquaculture operations? And I think where we've sort of settled in is they typically need to find wild broodstock in order to start the kelp aquaculture operations. So I think where this technology can help and where we can play a role is to try to map the wild kelp beds, see where they're flourishing, where they're doing well, and therefore, A, that's a spot for broodstock, and secondly, that shows that environment is a good one to grow kelp and so on. These were just some of the companies that showed us letters of support for the project, and we certainly appreciate all of their efforts. The next research question was, well, we need to develop more of a market for kelp. It's a fairly limited market at the moment. So Canada's Smartest Kitchen's role is, what can we do to produce not only snack foods, but I guess we could also think perhaps more health food, because as we were researching some of the benefits of kelp, the slogan, kelp is the new kale, was seen more than once, and all kinds of nutritional benefits that I think we're going to hear a little later on from those folks. And lastly, College of the North Atlantic. Unfortunately, our colleague who was going to join us in person ended up getting COVID late last week, so he's going to join us remotely to present on some really exciting technology they now have. They have bathymetric LiDAR on a drone, which I think could play a role for, say, surveying the farm kelp. To go out and survey a big area looking for wild kelp, drones do have a limitation in the size of the area they can do. The other thing they're going to work on is, this this is another colleague at CNA, is going to look at machine learning to try to predict the best places to grow kelp, so a straight-up GIS approach. So that is a kind of a quick overview of what the plan was and the idea behind it. Now I'm going to blast you through a whole bunch of data. So you may think back to that original map that had a bunch of little red polygons. This is what we ended up surveying. The Hawk down in southwestern Nova Scotia off Cape Sable Island, Eastern Shore Islands, and we want to acknowledge some of our colleagues at DFO put in some additional funding to expand this area. Drumhead and then Arichat, and then we'll move on to Newfoundland. So, where were we going to survey? We're not kelp experts at all. So we discussed with DFO different areas in Nova Scotia that may be applicable, Memorial, different areas in Newfoundland, planned the flights, coordinated with the Nova Scotia Aquaculture Association and Premier Seafoods to actually acquire some of the farm kelp to pass on to Canada's Smartest Kitchen for some of their work in the food side of things. And we collected most of our data in late June through mid-July into Newfoundland, and we followed that up with a series of ground truth campaigns to of course, better interpret and understand what the LiDAR data was showing us, collected more kelp, and eventually had kelp shipped over from Newfoundland as well. So, and when we were in Newfoundland, it's tricky going in an airplane with GPS gear and batteries and so forth, so College of the North Atlantic helped us out with some equipment when we were over there doing the surveys. I'm just going to give you a quick little smattering, and then we'll get into each site in perhaps too much detail, but we'll see how it goes. This is off of Arichat, just some amazing, there's a meter stick for scale, some beautiful sugar kelp that Ron Boudreau did some diving for us, and there's some digitata beside it. Now, on the flip side, down in southwest Nova, we actually saw alaria growing, which was the only place in the province we saw it. Otherwise, we mostly saw these two species of kelp. And I apologize for not giving the proper biological names and so forth. I'm just a geologist, so I look at rocks. I can tell you, I can expand those names fairly well. So what was involved in the ground truthing? We did, high-tech approaches, like a GoPro tied to a weight and then dropped. Others, we had a scaled quadrat on a pole. We're all doing this on our 18-foot Boston Whaler. We borrowed a little ROV from the CTAC group at the college and have a GoPro on it. And then a very useful piece of technology is the Biosonics Echo Sounder. So this fires at a certain frequency such that we can map the vegetation height and cover percent. It doesn't tell us exactly what the vegetation is, but it will give us some idea of what is there. It's a single beam echo sounder. Okay, let's now start at the Hawk again. And actually, these are a few little eye candy shots. It was by far one of our best data sets. So in addition to the laser system that I mentioned, the LiDAR is also equipped with a 60 megapixel camera that is red, green, blue, and near infrared. And this just shows some of the really nice imagery that was collected at the same time. You can sort of get a sense of where the flight lines went by this. And then we did follow-up work with the drops over some of these areas. This shows the LiDAR elevation model, and we can clearly see the difference in texture of the seabed. These smoother areas would be sediment, compared to these rougher textures would be rocky terrain that typically is where we have the kelp with the hold fast on that. So right away we have a textural component we can exploit when we start looking at trying to derive metrics from these data. Here's a few examples. So in some areas we had fairly dense, very dense kelp, and other areas fairly sparse. And then we do have a mixture of other seaweeds, fucus, and other material as well. So not perhaps as easy as we were hoping. And of course, the kelp doesn't have an air bladder, so it's not standing up nice like the rock we did. This is a track of the vessel with the biosonics, and I appreciate these dots are really hard to see here. But in essence, basically the brown areas are virtually no vegetation, and whenever you see the blues and the greens, we have higher vegetation here, 0.5 meter to 0.75 meters, and it correlates quite well. So we use that more of a ground truthing data set than we would anything else. This sort of demonstrates the problem and the challenges with remote sensing. Before looking through the water, really tough to see anything. Once we're under the water, of course, we can see this beautiful digitata. This was surveyed and ground truthed in mid-July, and we can see it's starting to degrade a little bit, the edges of it there and so forth. But fairly dense, very healthy looking stock. Quick shot up to Arashat. Ignore that. We want to thank Michelle Sampson of Premium Seafoods and Carl, and there's Carl and Ron Boudreau. Sorry, Ron, if you're listening. And this is off of Arashat, diving in an extremely dense kelp up in that area. Here is Arashat itself. This is in the southern tip of Cape Breton, and Petit de Gras is out here, and this is where we did some of the diving. We also explored various sites along here as well. Quick shot of the LiDAR. I don't remember the exact depth we got to there, probably about 10 to 12 meters if I remember correctly. On the Atlantic side, we typically do quite well, maybe sometimes out to 15 meters. This is some early work Kevin worked up. There's just showing that kelp again. Very dense. I'm going to move through this rapidly. The LiDAR elevation model on the left. This is Kevin working up the data, and he's going to give you a talk this afternoon to really get into some of the details where we're trying to look at seeing if we can see plant height above that. Looking at the point cloud, you can see the, the sort of more rugged terrain versus flatter areas. And this was an early attempt at looking at vegetation height, and we dove and have video on some of these locations. So let's just work our way through this. So you see we did quite a few sections of the coast. Certainly some areas were more plentiful than others. I would say this area that appears to be the most exposed is certainly where we saw the most kelp being grown. Unfortunately, that's why I showed you that picture of the hawk first. Those photos were beautiful. These photos, not so much. We had, unfortunately, to line up good tides, good water quality, like we can't fly when the water is turbid and dirty. We need to fly when it's clear. Sometimes we have to sacrifice the photo in order to acquire the LiDAR. The other thing I didn't show, I don't believe, was we actually also record the amplitude of the reflected signal off the seabed. So these dark and white patches here are showing us what's on the seabed relative to what the green laser sees. We have some data sets later on that are really quite useful for seeing that information. Here's the underlying elevation model, however, and just some areas. We did some follow-up work in October where we went out and did some video drops and collected more of that biosonics information. And you can see the kelp really has degraded quite a bit by this period of time. This is showing the that biosonics echo sounder. And really the correlations aren't so obvious there. Moving to area number 2 now. This intensity shows things a little better. If I go to the next slide, we can see we have a very smooth, even some ripples showing here. So we know that's a sediment on the bottom compared to the rougher terrain. And typically the dark areas are what we would expect for the kelp-covered rock. And as we move through and our drops confirm that, fairly dense kelp in some of these areas as well, quite a bit of mixture of fucus in here as well, though. Whereas out on that other shore, we mostly saw kelp. You can tell they spent a lot of time going back and forth here. I think we were trying to get a piece of equipment working and had some challenges. That's why they hung out in this area so much. Or maybe the waves were a bit rough and they just wanted to stay tucked in. But as you can see, going over that sandy bottom, no vegetation height, and we can see a fairly pronounced band. And if we go back, we can see how that correlates with the darker intensity map. Not much on this side, not nearly as pronounced. I'm just going to step through these real quick. So, you know, very little kelp on this sheltered side. So it certainly likes the wave action. Moving down the eastern shore now to Drum Head. You know, these surveys, oh, that's not a very big area. But in fact, you know, that took about 18 lines back and forth. So, you know, a whole afternoon of flying, an incredible volume of data to deal with as well. I'm not going to show you all of these areas, but a couple of them just to give you a sense. Photos, not bad for the near shore, but the water clarity was such we lose it fairly quickly as we move into the deeper water. However, this, I think, demonstrates one of the real benefits of the LiDAR intensity map. We can see much more detail of what's going on as we move deeper into the water and the variation between lighter colored material and darker. Not the same as backscatter on an echo sounder, which may tell us whether it's hard or soft. Remember, this is simply green light. So it's simply whether it's a lighter object or a darker object in green. And we can see quite a bit of variation as we move through that with the biosonics. And in some areas, you know, some fairly nice dense kelp, and others quite a mixed bag of sea plants. Similarly, quite a bit of variation here, and in some cases the laser, when we get into very shallow water, we get a bright return regardless of what the seabed shows. I know why I wanted to show this one. We can see here, again, once we're into this smoother terrain and more of a muddy bottom, then we'll typically have eelgrass growing in some locations. So we want to, when we're generating our cover maps of what material is there, which is our first step to try to get to estimate biomass, we realize we're going to have quite a few challenges trying to get biomass directly. We certainly want to be able to differentiate the eelgrass from the kelp and other seaweeds. And I think, you know, just because they grow in totally different environments, we've got a good chance to do that. Eastern Shore Islands, so up to Tangier and then past Ship Harbor, I believe it was. And I didn't count the number of lines here, but I know Nathan Kroll, who did the actual flying for us, we had several back and forth. You know, it's easy to sit in the office with a map and draw a polygon and say, okay, that's going to be the area we're going to fly. And then he plans it out and says, you realize that would take me 3 days to survey that? And so, you know, we had to constantly cut it back to get it within a manageable size. But the data turned out really quite nice. Photos, not so much, but here I'll draw your attention to all of the seaweed growing along the shoreline here. And the intensity, and we can see obviously the bedrock features coming, extending into the subtidal. And fairly barren for much of this flat, muddy bottom. And then where we do get the rocky outcrops, we start getting the kelp occurring. By the time we got to here, the kelp was starting to degrade a little bit in mid-July, but a mix of sugar kelp and digitata, and then other areas where not so much. We have these other sort of algae that aren't going to be easy to separate directly. In some areas, we still have a few challenges with our flight line. artifacts. And of course, we want to clean those up so as we put this type of data set into a machine learning algorithm or a classification algorithm, we don't have these kind of seams to deal with. And Kevin, I think, is going to touch on how we're going about that kind of process. And I should mention, these data are going to be made available. We're just trying to figure out at the NSCC how we can do that with firewall issues and so on, and working our way through that. You can see the water clarity here is now becoming fairly challenging. I question, just what the hell is going on in this photo. But a fair degree of eelgrass is the dominant thing we saw in many of these areas, and it relates to the seabed and the topography, the smoothness of that seabed as well. Now, going down to the Hawk, which if you've never been there, I highly recommend it. It's a beautiful white sand beach. You've got to be braver than me to go in the water, but my wife did, so good on her. But a beautiful spot, and lots of kelp here. We were quite impressed. So we're just going to show you a few of those areas. Yeah, the photo, this light doesn't really do it justice. In the photo, we could see a little more contrast, a few open patches here, and actually quite a bit of variation in terms of the density of the submerged vegetation. And that really relates to where we see dense kelp. And of course, this intensity really picks up, even better than the photo, the variations in subtlety in terms of the density of materials here and so forth, from the sand into kind of a mixed bottom into sort of denser vegetation. And again, this really correlates nicely with the roughness of the terrain. When we see these denser kelp areas they really love the boulders. And as I mentioned in the beginning, normally we were seeing mostly digitata, and in some cases, I don't see any jumping at me, a little bit of sugar kelp perhaps. But then this was, again, seeing Alaria down in this section, which we were used to seeing in Newfoundland, but had not seen any other place in Nova Scotia. Certainly didn't see any in the Eastern Shore or up in the Arishad area. Just a quick glance here again. I've reiterated a few times how the correlation between the dark, submerged, and the rougher terrain really correlates where we're seeing the vegetation. Yeah, it's a kind of a shame. Nice photo, a lot of drops. One thing we plan to do next year is to go out a little deeper and maybe try to run a few transects out deeper. This was getting near the end of the season, and we more or less did one trip up and back along the coast doing our ground truthing there. But some interesting features coming in, and again, no shortage of kelp. A little sparser in some locations, so to be able to quantify that and get it relate it back to the data sets at hand. Kevin's going to show an example where he's kicked the tires on a classification routine here to see about teasing these data sets out. And we're also looking at the point cloud level itself rather than these derived raster layers. You can see here the Alaria is starting to get fairly beat up with the wave action at this time of the year. Okay, let's jump to Newfoundland. Nikki, how much time do I have left?
30 minutes.
Oh, well, I can slow down a little. All right, so we went over here. The LiDAR was collected in July, but we went over here in late June. We actually did the ground truthing before the LiDAR was collected, just the way the logistics worked out with Dr. Gagnon and his team over there. Bay Bulls, Flat Rock, Baleen, and all based out of Munn at St. John. So there's Dr. Gagnon, his grad student Z, and another young fella, Zachary, who was an undergrad working for him for the summer. There's an unshaven me, Lauren Douglas, and Emma Lasky. The three of us went over and did the ground truthing with Pat. Pat had a nice, I don't remember the length of it, 22 foot, I believe. Zodiac, he's got a nice drop camera with a frame on it there, a little UAV, a little ROV system. And those were the main things we used to do our ground truthing. So he does have a, what's his echo sounder? Do you remember? The Lawrence echo sounder. So not quite the same as the Biosonics, but still an echo sounder that does give us some indication of the vegetation. Now, this Zodiac has got rubber sides, but a ribbed bottom, and we needed to have it on the trailer correctly, or else it could damage it. So one loading, the back end of it came on a bit crooked, and therefore we were kind of like, okay, we can't push it over up on shore, so we put the boat back out, and some schmuck had to volunteer to get out there and move it into place, and since I already had children, it was me. And we got her back into place, and Pat said, "You're pretty hardcore, Webster," and all in the name of science, I guess. So the drop camera would go down. We also took our survey grade GPS over there, so we had more precise positioning rather than just a handheld Garmin or a code-based GPS system. This is Z doing a interpretation and logging the information directly. This just shows the camera itself and its housing. We had a great time. We had a lot of fun and covered a lot of area, and the kelp situation there is quite different. The coast drops off a little faster, and the kelp is constrained to a smaller band along the shore, and there you can see mostly Alaria, a little bit of digitata in really great shape. Their little underwater drone or ROV system took just some really beautiful video. I'm not a diver, I've snorkeled, but it's kind of the equivalent of being a diver when you're tooling around with this thing. Really captured some great video. And this just shows, that was first Alaria in our foreground here. Moving up to some small digitata. And now, I don't think I show it in this slide, but also we saw many schools of capelin. And if you're not familiar, capelin are a small fish that comes into the subtidal zone, eventually to spawn on the beach. And we were wondering, how is that going to affect our LiDAR survey? Because the LiDAR certainly would not see through that, through those objects. We haven't really picked any schools of capelin out in the data set yet, but I must say the volume of data has been very large for us to work our way through. This is just a little video offshore. Could be the next Newfoundland tourism commercial. The vivid colors. I think the camera does a little bit of saturation of the colors myself, but we can see the relationship there where every boulder has the kelp growing on it. Skip ahead here. Now, we brought some of the kelp back. We didn't really have a good way to sample the kelp, but here's an idea of what we saw. So we saw the digitata, and quite a bit smaller than what we saw in Arichat. Now, there probably is larger samples growing. We just couldn't really get our hands on it. There's the Alaria, very fine material on the edges along the spine. And then one that we don't see in Nova Scotia, or at least we've never observed it, is the agarum or sieve kelp with the holes in it. And we definitely saw a distinct pattern that I think when I go through the slides, I'll try to recall. This typically grew in the deepest areas, and these were in the shallow. So we definitely saw a gradation of where the kelp grew in relationship to depth. Let's go to Bauline first, and quite a large strip here. And unfortunately, when we did our ground truthing on this site, it was raining fairly heavily, and it the ramp is quite steep here. So Pat being wise, and we didn't deploy the boat at that day. So what these are where we took the little ROV unit out and just collected some video of that area. Quite a bit of variation. A few scanning artifacts that we need to probably clean up before we push this through to a classification algorithm. But these darker areas are definitely dense vegetation. And a couple of screenshots. Now, once that little ROV goes out, it's a little bit tough to actually georeference exactly where it went. But that's a pretty good idea just off of these two shores here. Now, Bay Bulls, I should mention that Pat is doing a project of his own using UAVs, optical red, green, blue imagery, to go up and map kelp as well for DFO over in Newfoundland. And Bay Bulls was one of his study sites that he goes to quite a bit. So this is why we surveyed it in two directions to really increase our point density, and flying in those two orientations gives us, in case there is any shadowing effects or any biases, we should be able to compensate for those. So very rugged terrain, fairly steep drop off, and you can see we couldn't get too close with the vessel. These green dots are where we did the underwater video, and the red dots are basically where we did the drop camera with some additional underwater video in yellow here. You guys can't really see it, unfortunately, but we see some really dark patches in the photos here that represent where the kelp is visible. And this is confirmed with the LiDAR intensity. And here we can see, Agarum again being the deepest, and these are barren areas compared to where we did see some of the something else there. But we ran the video out, and with our own eyes, we could see very dense digitata bands up in this area. I think we had a whale out breaching at the time, so there was a bit of distraction, but we managed to try to continue with the work. There's a good shot. Unfortunately, we had a little droplet on the camera here, but digitata, and a lot of this stuff was almost right at the surface, washing back and forth in the waves, quite exposed. And we see a bit more barren area here. And one thing that we saw in Newfoundland that we really didn't see much in Nova Scotia were, an incredible number of sea urchins that were eating the kelp, and in some cases causing the barrens. We didn't really see much of that in Nova Scotia. Here we are again. This is submerged, and then each of these would be boulders that have kelp on it as well. I mean, both times we went out there to ground truth, the water was quite rough, and we couldn't get too close in fear of damaging the vessel and so on. You may notice this looks a little blurry compared to the elevation, and there we're sampling the data up slightly to get rid of any of the speckle that may come in from the multiple flight lines and so on. But that's a great example of what a lot of the bed looks like. And then, tough for you to see perhaps, but these little green clusters here are all of the sea urchins that are just having a field day with that much kelp around. And again, here's an area that's fairly barren and a few urchins still left. And there we see some more alaria and a little mix of digitata. Moving on to Chance Cove. We expanded the survey to include both bays, but we really, as you can see here, just ground truthed the one. It was a little, again, once we moved out near the mouth of the harbor, the swells were quite pronounced, and nobody really wanted to venture around the corner there due to safety reasons. Pretty good ortho photo. You can see there was some glint. We're still working, and I think Kevin's going to mention some techniques to try to deglint the data, or where we have multiple photos to go through the stack and try to take the best one. But this is sort of what's directly output from our Agisoft processing area and our various drops here. So if I just go back, maybe there's enough light, you guys can see the, the relationship to the dark patches that we can see on the photo and how those correlate fairly well to what that LiDAR intensity sees. So between the photo, the LiDAR intensity, the roughness, and the depth, we're starting to get quite a few variables here that that we can feed into some different machine learning algorithms to look at classifying the data. So I see we've got some agarum here, a few barrens, no surprise, rubble out here. I think it's flat rock where we really saw the gradation quite nicely. This is a nice slide, though, that we can see the nice smooth bottom and how that relates so easily to the resolution of this bathymetry. We're gridding this stuff at a 0.5 meter resolution, and it's really captures the seabed so clearly. And now this is the agarum. So you can see it has quite a different texture on the seabed from the Alaria and certainly the digitata. And another shot here, just looking. This is kind of my naming scheme, green seaweed. I guess we must not have been able to identify that one correctly, but barrens out here and one agarum at this location. Oh. Okay, flat rock, this was an area where we probably saw the most relationship between depth and different seaweed species. We did quite a bit of work working back and forth and a few transects. Pat, very familiar with this site. The LiDAR intensity shows some interesting zonation here of where the seaweed, is attached quite well. Obviously, we've got various geological fractures going on here and some interesting geology. Very challenging place to fly because we have a high cliff right here. So we're only flying at 400 meter altitude, so we need to always be careful about that type of survey. So fairly barren over on this side. Then we have this Marissa. Then moving out into finally the agarum. A little bit of Alaria here, but I think we have a spot where we actually see it a little bit better. More sea urchins in these barren areas. Wherever we see any kind of bedrock ridge or boulder, if the urchins haven't got there, good chance we'll see kelp. More along here, this was the boat ramp where I don't think actually that is the boat ramp where I had to go get wet, or maybe it is. Yes, it is. This one here. Now I recognize because people were up here watching us, and when I got out, they yelled down, "How was the water?" And they thought I had a wetsuit on, but no. I was smart enough to remove my phone. That was about it. So we went back here a second time on our survey. We always were looking at the wind conditions and where things were going to be exposed or sheltered. And again, these are some nice shots from their video system. So the vegetation's not sitting, super high, but we definitely see there's a characteristic signature in the roughness of the terrain. These barrens are going to be a challenge to figure out. And I think we'll rely on the intensity data here, seeing the difference with all of these sea urchins compared to when we see, in this case, a good amount of Alaria. Okay. Am I ahead of schedule? That is amazing. Well, I had 100 slides originally, and I thought, oh my gosh, that's way too much. So I think I only showed you like 95 slides. But there's time for any questions. If people have, I know I've taken you through a lot of different images, a lot sort of look the same and so forth, but I think that gives you a pretty broad feeling of the activity we've done on year one in terms of where we surveyed, what the data products look like to date, and what we've seen for ground truthing and what we've learned. So I'd be happy to entertain any questions. Yes?
Is this data going to be publicly available once you mentioned something about firewalls and data?
Yeah, so I mean, I've asked our system admin people, like, how do we make this available rather than a sort of old school FTP site? It'd be nice to have sort of a graphical GUI type of interface there. And they came back with questions about firewalls. So we're still working on that, but we are committed to making it available. Right now, we've shared it with our various partners via, OneDrive and so forth, but that's not a really good way to do it. So stay tuned there. We are committed. We just need to work with the IT people who have a lot of the power. Yes,
Somebody
Nikki.
asked earlier online if the presentations will be available after the event.
Yes, we can make PDF files, and again, where we put them, how we distribute them, we'll have to figure that out. I guess since we have everyone's email, we could put them on a shared drive and just email that location out. That shouldn't be too bad. And I believe, Nikki, the event is being recorded as well, so will that be available on our NSCC YouTube channel? Okay. But yes, we'll make sure the presentations are available as well. Yes, sir.
Do you distinguish near the end there between agarums and alarias? Was that all by ground truthing, or was there some way that you're all concerned that with the LiDAR?
At this stage of the game, definitely by ground truthing. And I hope I didn't delete it, but I thought I had a better slide, to be honest, that actually showed that gradation more clearly, because in the field, it was fairly obvious to us that, oh, now we're deep enough, we're only seeing agarum. And in shallower, we were seeing more of the alaria and the digitata, in Newfoundland at least. Yes?
Hi. So the thing is, between the different sites, I saw you might see different things with the distribution of the species, because Newfoundland is getting deeper and colder, so you might have more alaria rather than agarum rather than alaria is really sensitive to temperature too.
Yeah. I mean, that's why I was really quite surprised down at the Hawk in Southwest Nova when we actually saw the alaria there. I mean, because I kind of was thinking like, oh, these species in Newfoundland, the colder water, et cetera. And then we didn't see any of that in Arishad or the Eastern Shore, and here we are down in, I would assume, one of the warmer water, although it didn't feel very warm. And then we saw the alaria down on the southern tip of Nova Scotia. So.
We're talking about doing some ground truthing for the biomass as well. So are you expecting to have like categories of biomass? Because that you were saying, like the ground truthing is kind of difficult to do.
That was our original hope at the beginning of the project. We were hoping we would be able to do that. I must admit, I'm less confident of being able to get good biomass numbers. I mean, I think our first goal now are lowering our expectations a little bit. If we can map the distribution of kelp, great. Maybe we'll be able to do something about variation in species. That's getting a stretch. And biomass, I think there'd be quite a bit of uncertainty with whatever estimates we come up with. I think we can probably work the data to the point we can probably come up with some equation and make an estimate, but a high degree of uncertainty there. Just every time we saw it, it was all laid over on top of itself, and it just makes mapping that height, even though the biosonic sees a bit of height, and the LiDAR sees a little bit of height. When Kevin shows some point clouds, you'll see that it's challenging for sure. Yeah. Oh, no, please.
When we were talking early of the project, you were planning maybe on flying over some kelp farm. Did you do it at the end?
No, because we couldn't get the plane coordinated when the harvesting was. You guys were going to harvest earlier than we were ready with the plane, and I mean, I've thought about that a fair bit, and I mean, the kelp up in Arashat grew what, maybe 2 meters at the most? And it was 2 meters below the water, and some was even a little deeper. So I think the LiDAR probably could see it, but it's an awful expensive system to fly to see what you could go out and lift the line and see. Now, the drone may be more applicable. So this coming year, I'm hoping we can coordinate with the folks College of the North Atlantic, and I think the drone would be a great way to test on farmed kelp, how, you know, what we can do with that. And we may fly our plane over, not our plane, I wish we had a plane, fly our sensor over in a rented plane, you know, to correlate the results and see how it behaves as well. And plus, I want to fly the drone over wild kelp as well, just to find out what its limits are in depth and everything. So we didn't get to that point last year. And as I thought about it, I thought, well, you know, economically, it's not going to make sense for anybody to ever fly a airborne LiDAR manned aircraft over a farm kelp field. Although I think the idea of mapping the wild kelp is, you know, a useful approach. But the drone may be more suitable there, and we'll hear this afternoon from College of the North Atlantic. They've taken possession of it and are going to start doing some test flights. Yeah. Say that table, and then we'll come to you.
I'm just wondering if anyone's working on doing any genetic studies, specifically with that wild brood stock. We've seen in the States, in different parts, they have like regulations around how far you have to be collecting the kelp to grow it in an area, and I'm just wondering if anyone's actually collecting that so that we even know if there is any genetic difference or like what those distances might be.
We've collected it mostly to pass on to our colleagues at Canada's Smartest Kitchens. We're certainly not, but I see Flora.
I have a colleague doing that. I would explain this afternoon.
So this is, maybe Kate, you can put your hand up. You're going to meet these folks later on this afternoon, but Kate Collins from the Agriculture Association and Flora from Mironoff are also, both those folks are going to present this afternoon because they have similar, or I wouldn't say similar, they have complementary projects that are going on, and we've been it's been a very useful relationship there. Yes, sir.
So you said a couple of times in some of the spots where you were ground truthing, you stumble on fucus and things instead. So there's a lot of like canopy species or like understory species. Are you finding those were getting mixed in with the kelp signal a lot, or generally where it looked like kelp was it kelp that you were finding?
I mean, if there's stuff under the kelp, we're probably not going to see it. The way the LiDAR works and the dominant signal that comes back. And mostly when we ground truth, once we've seen areas that were dense kelp, you know, and other than trying to move the kelp out of the way, that's really all we saw. And then, you know, you did see some photos there where we see quite a mixed bag of, you know, fucus, some sparser kelp, and, you know, some other mosses and so forth. And there, that will give us that'll give us a little bit of a different signal than when we have those dense kelp areas. It's too bad the photos were a little washed out, because at the Hawk especially, and we can correlate this to the LiDAR intensity map, where we saw the densest kelp, we definitely saw an optical signal in the air photo, and that correlates quite well to the LiDAR intensity, the darkness of the LiDAR intensity, and sort of the roughness. Now, we haven't gone in there in a lot of detail and looked at the point clouds to say, you know, hey, how does this point cloud look? That's kind of the stage we're at now is, okay, we've got all these products built, and to just start looking at point clouds, oof, you know, I'd have pop bottle bottom glasses, even worse at that stage. So we make these raster products first to get a sense of, you know, the terrain, the roughness, the LiDAR intensity, the photos, and then we'll sort of hone in on now the point cloud work. Those initial point clouds were some things that I had asked Kevin to work up, because when I came back from Arashat, I was like, whoa, that's the mother lode in Nova Scotia of kelp for sure. Unfortunately, when the survey took place, water clarity conditions weren't great, so we don't see much on the air photo, but we do in the LiDAR intensity, and the point cloud, as you saw from those first couple of slides, looks encouraging. So, long answer of... Yes.
I have a question from online. It's kind of similar, so sort of repetitive.
No, it's good.
Do you have some ideas about how you distinguish kelp from other seaweeds in Nova Scotia? Canopy height is one option, but it won't be consistently different between the kelps and other seaweeds.
Yeah, I mean, that's a great question. As I say, we saw some differences there in the hawk in terms of where we saw sort of homogeneous kelp, nice and dense. We saw that the air photo reflected that in terms of its darkness of intensity. And certainly the roughness we can exploit, but you know, if we had kelp roughly the same height as a bed of fucus beside it, I would not want to bet my life that we're able to separate them. I think that's going to be a real challenge. Now, we haven't really gotten to that level of our analysis yet to really kick the tires and try it, but that's kind of my gut feel, unless you know, Kevin says, no, Tim, I can do it, and which wouldn't surprise me, but I don't think we're quite there. So there's some challenges for sure.
Were you guys taking locations that you flew over? Were you guys taking any other like environmental condition parameters, like temperature? I don't know, closeness to anthropogenic sources of nutrients, things like that.
No other sort of analytical information, but of nutrients or things like that. We do have temperature recordings at the time we did the ground truthing based on the biosonics, but that's it. But I do know, was it Kate Caves did a nice research work up in the Arashat area looking at, and I believe one of her outcomes that I picked up on when I saw her defend her thesis virtually was, you know, freshwater inputs showed that maybe the kelp wasn't doing as well and so forth. But no, we have our hands full just with all of this gob of data, so haven't done any other work like that. But I mean, if people are doing those kinds of studies and so forth, we would love to sort of team up and see if there's any relationship or correlation, et cetera.
Like, it could be interesting if there's a place that you're flying over frequently, and we can put some sort of monitoring equipment there, and then I don't know, just see how, maybe 3 sites, just see how it compares.
Yeah.
Like why it's been where, basically.
Well, this afternoon we're going to talk about, you know, we have one more year left. We have one more flying season left. So, you know, we're open. When you say flying over frequently, that's, I mean, sure, we could fly over like a couple of times in the summer, but, you know, are we going to gain much? It'd be awesome to fly over something maybe a few times a year for multiple years, but funding doesn't really easily allow that. A drone, maybe, you know, that's the beauty of a drone, but we'll have to see how that works out. Yeah, so we're certainly open. Nikki's given me the 1 minute signal, so that's good. I believe now, I moved my agenda. Okay, Arisha, you're going to present, I believe? Or, okay. Thank you. Lauren, would you mind moving your laptop over? I found mine. Introduce your team, Tim. Okay, so I will briefly introduce Dr. Tim Roberts of Canada's Smartest Kitchen, and he'll introduce the rest of the team there. I found that lip wasn't enough for mine. I don't know. Thanks, ladies.
Yeah, thanks. Yeah, you can, yeah, whatever works, yeah.
Just so we can see your face.
Okay, and we okay to flip over to this?
Yeah, we
Yeah.
can do that. Just.
Great. Thank you very much, Dr. Webster. That was a great start to the day, and I just wanted to quickly introduce the team at Canada's Smartest Kitchen and the work we're doing at Holland College. So we were really, really excited when the initial call came to see if there was a partner opportunity with this project, and right away we said, absolutely, we would love to get involved with Nova Scotia Community College and College in the North Atlantic with this research, and really bring the work that we do at Canada's Smartest Kitchen as a technology access center at Holland College into this project. And really the piece that we're looking at is finding kelp, looking for kelp, understanding kelp and all this growing and what's happening, which is great. Can we present some ideas as to how kelp can be processed? And we knew really early on that the team at Canada's Smartest Kitchen would be able to do this and really take a broad scope approach in year one to really explore how the kelp as a raw input can be processed and turned into different inputs for food product prototyping. So the team has worked really, really hard on just this, as I said, this wide approach to coming up with really different foods that we think could be, that you could see how kelp can be incorporated as a viable ingredient in products. And we wanted to do that because we wanted to set a stage to hopefully refine the research that we want to do in year two. And we'll talk about this a little bit more this afternoon, but more as how do we approach commercialization and things like that. So we're taking this broad funnel approach and bringing it in. So the team at Canada's Smartest Kitchen, there's a couple of individuals who are not with us today. We'll talk about them in just a sec. But the team has really worked in this space here. And a lot of that takes place, there's some individuals who have been to CSK before, and I know others maybe have not, but we are an R&D kitchen, and so we're actually prototyping on site and using various pieces of equipment to do that with our team. So we're working in this space, and what we're trying to do is inform that commercialization question. So two people that can't be here today is Senior R&D Chef Michael Bryanton, which is just, an image of him is just up here. Michael has been working with the team and bringing his culinary expertise into play and then supporting all of this R&D. And then Alex Gallant-Wood is a product developer at Canada's Smartest Kitchen. She's been helping out quite a bit, and Alex has a wonderful technical eye and can work in that way. Alex is also a registered dietitian, which is a great addition to this project. So she's been able to help us understand some of the nutritional components as well. But with us today is our research student intern. June is right here with us. And besides June is Elliot Seneschal, product developer at CSK. And Arisha Siris has also been working very diligently on this project with us. So again, as a product developer, Arisha and Elliot, June, and the whole team have been coming up with all these products, and we're sending information along to our partners and having discussions like that. And hopefully today, what you're going to see is, the team has brought some samples that we can try, and also on the table on the other part of the wall there is some samples of how we've been processing the kelp. So you're going to see some freeze-dried samples, some smoked samples, powderized samples, and things like that. Because we did know early on the kelp, in many cases, needs some form of processing to become whether it's more shelf stable or more easily incorporated, how it can also easily become an ingredient substitution, those kinds of things as well. So we brought in some samples there. So the most important thing, though, is for me to stop talking and let the people who have been working on this project so diligently take over. And I'm going to hand it over to Arisha. So thanks to everybody for that. Arisha.
Hi everyone. So like thanks to Tim for the introduction. My name is Arisha and I'm one of the product developers at CSK. And one of the big projects that we got to work on this year has been on kelp. Just to start off, all the samples that we have received, we started off with sugar kelp. And we worked on that for maybe about 2 to 2.5 months, developing ideas and products on how to make sugar kelp more edible for the Canadian market. Then once we had a couple ideas and we got a few more samples, which was the digitata, we did quite a bit more work on digitata. And agarum and alaria were the last 2 samples that we got. So we did do some work on these 2, but not as much as we did with sugar kelp and digitata. And we have a few more slides further down where you will see a big range of the different types of products that we have worked on. Like Tim mentioned, on one of the tables in the back, we do have a few samples for you guys to look at. So starting off with sugar kelp, when we had received the sugar kelp at CSK, they were all freshly collected samples. So what we did was we separated all of them and vacuum sealed them and froze them just so we can have enough sugar kelp to work throughout the rest of the months. We did the exact same with all the other samples as well. Digitata, this was a fairly interesting sample to work with because what we found was comparing that to sugar kelp, digitata had a bit of a slimy outer layer to it, which we were not expecting to see. So we figured, well, let's just kind of think of what we can do with that. And in another slide, you'll see kind of what we came up with. But it was really weird and interesting sample to work with. The last few that we got were alaria and agarum. These 2, we were not sure what to expect, but they were quite different from sugar kelp and laminaria. So like even the texture, when you're like touching them, so like I mentioned, digitata was kind of slimy. Sorry, but sugar kelp was fairly soft and tough, but agarum and alaria were both very different from that. So agarum was quite a much tougher and like not as bendy texture, and alaria was mostly just stipes. That one you could barely see the blade to it. Not a lot of leafy part, I should say. It was really a lot of stems to it. So the idea, what we ended up doing as a team was to try to think of taking all the attributes of all the different types of kelp and seeing how we can process those and what we could come up with in terms of using them in different food products. But in order to be able to do that, we had to really look into the texture and the thickness of them as well, and how to process them. So like I mentioned before, sugar kelp, fairly easy to work with, and majority of the products that you would see on the market right now have sugar kelp because, for one, it is known to have a higher carb content, a higher sugar content, hence the name, and that also comes from the mannitol amount that's present in the sugar kelp. Majority of the sugar kelp that are sold are about 15% dried, and that's one, to be able to make it more shelf stable, and a lot of people tend to rehydrate that to be able to use that in their food products. Digitata, like I mentioned before, a bit of a tougher kelp, but not as bad to work with if you can, remove that slimy layer. But the cool thing with that is if you, for those who have worked with digitata, if you grab a whole front, for one, it's fairly heavy, but that heaviness also comes from the slime. We collected the slime apart and we were just kind of examining it, and we thought this kind of reminded us of egg whites. So then we thought, what are the applications of egg whites? Well, a lot of people have been using aquafaba as an egg white replacer. Can we do the same with the digitata slime? So we did. It whips up really great. The only issue to that is the taste. It is not pleasant. But we're working on that. We're working on that. Moving on to the agarum. So that one, like I mentioned before, it's a much tougher leaf. The cool thing about it is it's got little holes in it. So one of the samples that we brought at the table in the back is a freeze-dried sample of it that was boiled for a while to see if we can get the leaves to be a lot softer, and then freeze-dry that. What we found was it does help, but not to the extent that we were hoping. It does make it a lot softer, but it's not as great. And also, once you start boiling the kelp, for the first couple of minutes, it has like a vibrant, bright green color. However, the more you boil it, the more you degrade the chlorophyll amount, and it goes back to being brown again. We did do a couple of freeze-drying trials with digitata that was blanched, and we found that if you take it out of the hot water when it's still like nice and green and then freeze-dry that sample, it still retains the vibrant green color. So that could be a decent application in terms of using that for color as well, and not just for the nutrition amount, the nutritional content. Lastly is the alaria. Like I mentioned before, alaria is like 90% stipes. Really, really tough to work with, but what we ended up doing was, again, blanching, boiling, drying. We did a couple of rounds of dehydrating the alaria completely to about 1% moisture, and then powderize that. But what we found was once it, if there's any sort of like bigger particles and you try to bite onto that, you can feel how hard it is. But still, we still found that, you know, powderizing the dried kelp with agarum and alaria tend to be the best ways to use these two. So I'm going to move on to Elliot, who's going to introduce all four types of kelp.
Yeah, good morning, everybody. As Tim mentioned, I'm one of the product developers at CSK. I've only been there for 6 months, and this is the project I was first thrown into, so this was interesting. I've never eaten kelp before, but as a chef, I've seen it around, but it's, in this term, it wasn't very, it was interesting to see it. So yeah, we were trying to identify different kind of usages for kelp. It's the most widely used product, sugar kelp is in some of the kelp-based products that are currently out there. You'll see why a little bit later on in that. Yeah, so the uses that we found, you can use it fresh, you can use dried, fermented, powdered form, very versatile because of its thinner texture compared to the digitata. It was a little bit easier to work with, so that worked out really well. It worked well for pasta sauces, jerkies, snacks. We have a kelp kombucha and elderflower, which is here to taste, so everyone can try that out. So that worked out well to pair some of that umami flavor into a kombucha. It was good for salads. We did a couple different salads for another presentation that we did with Tim when they came to Holland College, so it worked well in terms of texture into the salad product. Low protein quality and high carbohydrate, yeah, so the maltitol, a lot of carbs, and this, hence the name sugar kelp. But gives you a little breakdown here, the nutrition. As Tim mentioned, Alex Gallant-Woods is more the nutritional one, so I'm doing these slides. I understand it, but she's more in depth on this. Hopefully she doesn't judge me too much on this information. But yeah, as you can see, riboflavin, good source of riboflavin, sodium, iodine is probably your biggest one. So you don't want to eat too much kelp, but eating some kelp is also beneficial on that end. So good source of vitamin B and vitamin B12. So she had different sources. It was kind of hard to find some of the nutritional components, a breakdown for this, but a lot of research went into that from Alex on that end. So yeah, the next one was digitata. As you can see, there's the there's the egg whites, or the whipped egg whites, as Arisha mentioned. It was a great idea. Try to see if we can incorporate something different that wasn't aquafaba. And as she mentioned, it worked out really well, except for the flavor. I wouldn't eat it. I wouldn't replace it with your egg whites. But it was interesting. It's these kind of experiments that allow us to really identify. If it tasted really good, it could have been a really good source of an alternative to those other products. So yeah, we've made different products like compound butters, kelp puffs with seasoning mix. You'll see that as well. The kelp puffs are here. Fish analogs is a growing industry in terms of vegan fish analogs. So incorporating kelp products into that analog to impair a sea flavor was interesting as well. Chocolate mousse and chocolate truffles. The chocolate truffles are here as well, so you get to try those in the afternoon. But yeah, very versatile. But due to its texture, thicker texture, it was a bit more challenging to work with in a fresh format. So it was mostly powderized or smoked and then powderized in that format. Nutritional there as well. As you can see, it's very similar to the kelp, the sugar kelp. Yeah, nothing jumps out in terms of the iodine is still ridiculously high, which is to be expected. But it's important to note that it varies. The nutritional will vary depending on where the area in which that digitata or sugar kelp is being grown and cultivated. There's environmental aspects to it that'll impact that. But this is just a general idea of what that looks like. And then there's the agarum. As you can see, visually very appealing. Texture was a little bit different on this one as well. We did some sous vide experiments at different temperatures and times with different acids and other components inside with the sous vide to see if we could break down that texture to just make it a bit more useful. But once again, we went to the powdered format. It seems like it would be more realistic in terms of if you're going to scale up in manufacturing, how would somebody sous videing large quantities of kelp wouldn't be very useful. So powderization and drying would be more the use that they would probably use for that. So past trials, kimchi bruschetta, slaw salads, and shortbread cookies. Arisha made really good shortbread cookies. You eat them and you're like, oh, is there kelp in this? And there is, but you don't taste it, so that's good. And that was like the really big challenge for us, is understanding, do you want to taste the kelp? Do you not taste the kelp? So there's challenges where you taste it and you're like, oh my God, like this tastes way too much like kelp. And then there's other times it's like, oh, there's no kelp in this. And it's like, I like that. I can eat this. So that fine line was challenging. This is the wing kelp. As you can see, this is a freeze-dried, stipe that was in there, and that was interesting to see what it looks like. It's very nice. Yeah, we did the pickled form. So what we were thinking about is you look at an extreme bean that goes into a cocktail or something like that. So try to see if that would work in that application. It did work well. It's a different format, different texture, a little bit stringier or a bit more fibrous in that regard, but it's a good alternative to that. Oyster mignonette was done. I know that when Tim and the team went through with some individuals that hadn't tried oysters before for the first time, so they were pretty happy about trying it with the addition of kelp, as well as some sauces and some sweet applications for it as well. So, yeah. There's the nutritional there for the wing kelp, very similar to the other products or the other kelp varieties that were there. Yeah, so doesn't change very much from one kelp to the other. So yeah, so some of the market research that we did in terms of these products, we are linked with Food Island Partnership in PEI, and they have access to a report generating system called Mintel, which generates market data on information out there about products. So we went to them and said, hey, we want to know as much kelp-based products that are out there in the world, and see if we can identify some of those products. So they came up with 239 different sea-based products or kelp-based products across the U.S. and Canada. And yes, it's 1999, so there's a lot of them. Most of them were imported into Canada and the U.S., but nonetheless, there was some data information on that. So yeah, as you can see, some of the products, the snack category dominates a lot of those kelp-based products, and then followed by the ramen and instant noodles. Most of those snack-based and instant noodle products were imported from Asian countries, which is more the style of foods that they are accustomed to. And what we've seen as well, that it's the type of food that people seem to enjoy, and that it's the incorporation of kelp into those was a lot easier. Soups and seasoning as well were important. You'll see the seasoning. We did the barbecue seasoning for the kelp chips, which is really good. June, the intern, did a great job on that. And then, yeah, so the reason we were wondering about was the addition of kelp into the product, and understanding why is the kelp being added in there. Is it just to be added to say, hey, there's kelp in it? Is it providing a benefit? So most of the products that we've seen, 122 of the products, is just as a flavor base to add that impaired flavor of kelp into the product. But a lot of them are making it health benefit claims. There's some health claims onto the actual product as well. So those are the two main dominating components to those products, which was interesting. Yeah, so the unspecified kelp was, they don't actually specify which type of kelp they were using in some of those, but dulse was the one that was mentioned the most as a single kelp variety, and then it just varies from there and is in a wide range. So it was pretty interesting on the varieties of kelp that were being used out there. It's hard to get the information as to where that source of that kelp is from those manufacturers. We have to dive a bit deeper into that, and that's some things we'll look into the next year. And on top of that, we tasted a lot of kelp-based products. Some of those 223 products, we searched the web for a variety of different products, and we had tastings with some of the product developers to identify what the taste is like, what are the consumers, or what the development of those products look like, and the flavor profile. So we really identify that a lot of those products don't really taste like kelp. Some of them do, some of them don't. And yeah, they range. So the baby food ones were very interesting. Those were yeah, I haven't eaten baby food since I was a baby, so that was crazy. But yeah, that's pretty sums up the market research. And I'll hand it back off to Arisha there to keep going with that. Thanks.
So part of the idea of conducting this project was to understand all the different types of kelp that we have on the coast, and how we can use them if they're actually edible enough after being processed to be able to use in different products. Once we actually got the samples, we started thinking, what would be the different methods to figure out how we can break down the tougher outer layer to be able to process them even further into different meals. So we came up with the idea of using fermentation for one, or even trying to figure out if heat or acids can break down the structure. So some of the work that at the very beginning was done in trying to understand how to break down the different kelps that we have. And like I mentioned before, in the back, I believe we brought samples of dehydrated, freeze-dried, blanched, and powdered kelp samples. They're all, the four are vacuum sealed, so these ones you would only be able to just kind of take a look at them. But the powdered ones, you can open them, get a feel of them, see how it looks like, even taste it if you want. They're all edible, I promise. Yeah, and the other big component of this project was understanding the nutritional component of the different type of kelps. From all the research that Alex actually did a big chunk of all the research on this project, we found out that kelp, depending on where it's being harvested, it has a different nutritional composition. So one of the things that we wanted to do as part of this project was to try to figure out how the samples that we have, what they're made up of. So we did send out a list of all freeze-dried samples of all four to one of our colleagues at at Holland College, so they can run a bunch of tests to figure out what is present in the different samples that we have. Yeah, and on one of Tim's slides, I remember, I think it was on Digitata, or maybe Alaria. You had like the little white dots.
Oh, yes.
Yeah, so that was another thing that we were interested, because one of the samples that we received from you guys was sugar kelp that was covered in like little white dots. So when we saw that, we were thinking, what could potentially be that thing? So we did a couple more research on that and figured out that they're just microorganisms that are present on the kelp. And you know, heating, boiling, or whatever else that you do to it, you can still eat it. That'll be fine. It's all dead anyway. But we still did not. We chose not to use that sample, and because we still had a bunch of different ones. Yeah. The other section of this project was to try to understand what is this historical aspect of kelp consumption in the North American market. So something that we're going to delve more into in the second year is trying to talk with different, I guess, people from different cultural backgrounds to see if they have been exposed to kelp, if they have kelp as part of their dietary intake, or if they do, what are the different types of kelp that they would have been using in their food. Yeah. So unfortunately, most of you guys were not around at CSK back in November, but the ones that were had a fantastic array of foods to try. Yeah, so the next few slides would basically go over all the different foods that we've made so far and the pictures that we have, just to kind of give you guys an idea of all the work that we have done at CSK up until now. The first slide is a combination of slaw salad that had blanched sugar kelp in it. The middle one was a fresh oyster with an Alaria mignonette on it. And that one was made using pickled Alaria that we had prepped and pickled for, I believe, almost a month. That would be the second one in the middle.
Oh.
The oyster. Yeah.
Oh, the oyster.
Yeah. that had the pickled Alaria in it. And then the last one, which is that one, was the 4-bean salad, which again we used, instead of using pickled green beans, we chose to use pickled Alaria in it. And moving on to the second photo, that one had, again, blanched sugar kelp. At some point we ran out of sugar kelp, so we ended up purchasing, I believe it was from Maine Coast Sea Vegetables. We purchased a bag of dehydrated sugar kelp, and that is what we've been using to continue on the work. So as you mentioned, if you still have some frozen ones, send it over. We'll be using it. And then the fish analog had dehydrated powdered digitata in it, just to kind of simulate that fishy flavor that we had talked about. The tartar sauce had the pickled stipes in it to bring out a little bit of that acidity that comes with the pickled Alaria. And the fries were made by June's Kelp Seasoning. He was the one that came up with the idea to make a seasoning pack, because one of the products that he had worked on has been making noodles, like instant noodles and instant noodle broth, using kelp to simulate an umami flavor, a fishy umami flavor in it. Yeah. So we thought, well, if you look at a lot of the use for kelp on the market tends to be more leaning towards savory products. And one of the things we wanted to showcase at CSK was not just focusing on savory foods and the umami flavor, but trying to figure out a way to balance the umami flavor with more of a sweet component, adding a sweet component to it. So this is one of the desserts that we served during the November workshop, and it is comprised of a layer of a garum shortbread, and then on top of that, a cranberry apricot curd to kind of add a little bit of acidity to the overall mix. On top was a chocolate mousse that was made with powdered smoked digitata. And the idea for that is smoking, we found, brought a whole new and more complex range of flavors to the kelp. And what better way than to mix it up with chocolate? I mean, everybody loves chocolate, right? So yeah, so we combined that in together, and it turned out to be really, really, really pleasant. The chocolate, the dark chocolate compared with the smokiness of the digitata was a huge hit. Cover that up with some white chocolate glaze, and just to kind of make the plate look prettier, we made some kelp caramel to kind of go with the dessert, as well as some smoked digitata powder on the side. Yeah, so a few more samples of the food that we had showcased at the November workshop. As you can tell over there, these are one of the samples that we brought for you guys to try as well today. The kelp puffs. Those were a huge hit with the people that came at the workshop, so we thought might as well bring that again today so everybody else can at least get a little bit of a taste of it. Together with that was something that we made, a jerky type. The idea with that was, on one of the other slides, we did add on there that kelp does have it does have some protein in it, but it's not a significant amount to be able to say that there's a lot of protein in kelp. So what we ended up doing was we looked at a range of different legume-based, plant-based protein to see how we can complement the amino acid present in the protein in kelp with other plant-based protein. So then we came up with making a jerky type of extruded snack, which had sugar kelp in it, combined with fava bean and chickpea protein as well. All of those three combined together to give us a high protein snack. We wanted to call it vegan jerky, but the feedback that we got was this is not really jerky, so that's why we went with jerky type instead of calling it vegan jerky. As well, like Elliot mentioned earlier, we did do a couple of compound butters with the smoked digitata. One was the maple and the other one was garlic, kind of a sweet and savory combination, comparison of both of them. And also looked into doing a variety of different baked goods. With this one, however, we found that powdered was the best because we did try using a rehydrated sugar kelp in different sourdough loaves, and we found that the texture, once you rehydrate it, it becomes quite a bit chewy, and you don't really want chewy bits in your bread anyway, so that's why we ended up choosing to do a powdered version of the kelp in different bakery products. The pizza on the one side is kind of June's baby, actually. When we started looking into doing different food products, June came up with the idea of, actually, why don't you talk about it? The kimchi, the kimchi sauce and the pasta and everything else that you did with it. That's fine. You both worked on it.
So it's kimchi pizza. So I used smoked digitata powder in it, but it's pretty dry. So we had it on the 8-course menu, but it didn't really work out that well. So we kind of removed it from our list. But then also the kimchi, the sauce, Jillian, one of
the other interns.
Yeah, we talked about making kimchi with kelp. It actually turned out pretty good, but then we made it too spicy, and then we both kind of discussed about like using kimchi sauce on the pizza.
Okay.
And it was still spicy, but it was okay. But then we just couldn't really continue doing that because the dough was too dry because of kelp. Yeah.
Yeah. So. Just, as we go on making a bunch of different products, we started noticing, like, okay, so A, B, and C works great. C, D, E, not so much, but there's still potential there. So in year 2, we're hoping to take some of the products that didn't quite work out well in year 1 and seeing if there's any other way that we can improve on these formulations, anything we can add or remove, but trying to maintain a 5 to 15% kelp composition, because we don't just want to add like a pinch of kelp and be like, oh yeah, so the pasta sauce has kelp in it, but it's really very minimal amounts. We've been targeting, in each and every recipe that we have made so far, we've been targeting a range of 5 to 15. So at least, if anybody looks at the ingredient list, they'll be like, okay, well, there is a decent amount of kelp in that product. Yeah. like I mentioned before, there's quite a lot of products that we have worked on, and this is just to kind of give you guys an idea of the range of formulations that we've worked on so far, and there's quite a lot more to come. Like I mentioned before, yeah, so we're looking into the ideal range that we have worked on has been 5 to 15, but and this is also all processed and dried kelp that we've been working on. So the flavor and intensity of the kelp tends to be a lot more intense in a dried and powdered form as compared to using fresh, which is why we used a lot less of it. Yeah. So these are all the different products that we have worked on ever since we started on this kelp project. I wouldn't say all of them have been fantastic, but we have tried our very best. Yeah, but there have been some that tasted really great, and others, like Elliot has mentioned, some of them you taste it and you're like, oh, is there kelp in there? And then others that you're like, whoa, that's not for me. Yeah, but it's been a great time and a lot of a huge learning experience for us as well, because majority of our team have not really been exposed to eating kelp, and if you do, it's mostly in like Asian style meals, because they're the ones that usually tend to use a lot of kelp and like focus more on that umami flavor. You don't really see a lot of kelp in like sweet goods, for example, but this is something that we thought would be a really interesting market to enter, trying to figure out a combination and a balance between doing sweet and savory umami combination of all of those together. So hence quite a few of those are dessert style products with sugar kelp, and like I've mentioned, yes, that's actually, if Ellie wants to talk about that, it's one of the projects that we played with, and
we have capabilities for doing distillation at Piano's Harvest Kitchen, so we looked at creating a gin base that was, and through the column we would have a basket where we would stuff as much kelp as we could into the basket, and through a distillation process, it would impair some of that umami flavor through the gin, and it worked out really well. And there are some kelp-based gins out of Newfoundland and other places in the world, so it is a viable product that's currently out there. But yeah, it's fun.
Mm-hmm. Yeah. And like I mentioned before, a big chunk of the developmental work that we have done at CSK has been focused on sugar kelp, because that's the main one that we had beginning of this project. And then as we started getting more digitata, garum, and alaria, we started focusing more on trying to figure out how we can incorporate the flavor, the texture, and all the different characteristics of those kelp to try to see and find something that would mesh well with the kelp and the type of food that we're trying to create. So for example, the kelp puffs that we brought samples of today, that one uses tapioca flour to kind of create sort of a sticky dough. And we thought, well, with digitata having a lot of carbohydrate to it, which again comes from that sliminess of it, maybe that would go really well with as another thickening agent into the mix. So that is why we decided to go with using digitata in that dough, for example. When we were making the pasta sauce, to try to get a thicker one, instead of having to cook the sauce so much to thicken it down, we used a little bit of digitata to kind of give it a bit of a thicker texture as compared to like really runny pasta sauce, which nobody really wants to use that. Yeah, so that was kind of the idea of that, or I guess the path that we took when we were developing the formulations, developing the recipes, was trying to figure out what are the characteristics of the kelp and how we can use that characteristic to develop formulations that would mesh well with the different kelps. Yeah. Just to kind of quickly go over that slide, the idea for year 2 now would be to continue on with the developmental work that we have been doing in year 1, and revisiting a few of the formulations that didn't quite work out, like the slime meringue, for example. I personally think there's a huge potential for that. However, we need to work on the taste. That's, yeah. and as well, we're going to be looking more into the nutritional component of the kelp and try to see how we can use that information to further to continue on with the work that we're doing at CSK. Yeah, and I will go more into detail on that slide further down in the afternoon. Yeah, so that's all from CSK. If you guys have any questions, please feel free.
There is a question online.
Yeah.
I'm just going to grab, actually, I'm just going to come over here so that people can hear the question. Did you measure levels of cadmium in the kelp? I've read that high levels of odium and cadmium mean that sugar kelp is high in heavy metals, which limits its food potential.
That is something that's part of the research of the test that we have sent out the samples to. We don't have the data for that yet, but that's sort of the work that we're hoping to do in year 2 to analyze the nutrient content, vitamins and mineral content of the kelp samples that we have in order to figure out if, well, what else we can do with it. Yeah. Any other questions?
Did you all have like a favorite product that you either researched or found or that you made yourself? Is there something that kind of surprised you that you really liked?
I would say almost everything that we've made has been a surprise. Like I've said before, kelp is not really the type of food that you would, I guess, want to go towards and like want to eat. But I think we've managed to successfully fool a lot of people into eating them. No, I shouldn't say that. No, but we've been quite surprised with some of the feedback that we have gotten. There's been products that people have been like, oh wow, like this is just not for me, and others that were like, actually really like that kelpy, seawatery taste in this product. So, yeah, I'd say I don't personally have a favorite. I don't know about you guys, but I tend to like sweet and savory in general. So for me, like, I don't mind it. Yeah.
Yeah, I don't mind the taste of kelp, so.
Anything else?
Are there any products that are all in on the kelp flavor? They try to really bring it out in almost an aggressive way in the other direction that has been successful? Or I'm just thinking like dulse, which is a bag of dulse tastes like the ocean, right?
Yeah.
Is there any is that worthwhile or is that not?
I would say if you're looking to make a product that has more of a savory aspect of it, like for example in the fish analog, if you're adding a lot of kelp in it, that would go really well because you're expecting that seawatery fishy flavor in something like that. So in that one you can even look into like using 15-20% kelp and it wouldn't be an issue. People would not be averse to the taste of it, but if you're thinking of adding like 20-25% of let's say a garum in a chocolate truffle, well, good luck getting people to buy that because, I mean, there might be some people that are really into the seawatery taste in chocolate, but majority not so much. Yeah. So, again, depends on personal preference, I would say. There was a question in the back.
Oh, yeah. And sorry if I missed this. What's your, like, who tests the product? Is it just the team, or do you have, like, a sort of standard, group that you use? Like, what's the process there?
You mean like sampling all the foods that we've made? That's usually using the, we would do like an internal sensory with the entire team. So anytime we come up with a formulation, then we would present it to the team and ask for feedback if there's anything that they feel like we need to change or modify or increase or decrease, that sort of feedback. And then part of year 2 is running a full sensory panel on selected products. So what we have been doing so far, I believe it was sometimes in August, we ran a 10-person panel with people from the community, and we presented them with a variety of different products and collected the data from that. And then based on the feedback that we got from running that small sample, then we catered the rest of the formulations that we had towards improving the products that we then served during the November workshop. And then now we've taken that data as well to try to finalize the formulations that we have. And in year 2, we're hoping to run a proper sensory panel with 60 plus people from the community to come in and sample 3 to 4 of the selected formulations that we've decided we would be looking into commercializing, potential commercialization of those products. Yeah.
Thanks. In terms of food safety standards and the kelp that you received, do you have any sense of what the process was in terms of how it was processed or how it was harvested and kept on the boats and transferred to you? And then also in that primary processing factor, like is there a difference if you're blanching or dehydrating or powdering that the standards for how that kelp is processed is different? Because I know that will be limitations for some farmers.
We did get the data from a collection from Dr. Webster and Dr. Gannon because they've been the ones that have been sending us the samples. So in terms of collection and storage prior to it reaching to us, we do have that. They would usually tell us how it was stored, at what temperature and everything. And as for the processing, that is something that we're hoping to have the results soon. So we've sent samples of dehydrated, blanched, and freeze-dried different types of kelp. And once we get that data, then we'll be able to understand a lot better of how, because we also have sent out frozen samples too, so we can compare how the different processing steps have changed the composition from fresh. So once we get all that data, then we'll be able to do a lot more work in year 2 for that.
To go back on this question, how long was it for between the sampling versus when you received them?
The samples are usually sent to us within a few days, I would say.
Usually, like, sugar kelp, the shelf life is between 24 to 48 hours.
Yeah,
So
the kelp that was harvested in Arisha,
yeah.
Our team got it right off the boat in coolers with ice packs that were contained so that fresh water wouldn't leak out into the kelp. They drove that to Truro, met Michael, who we saw, and then he took them to the island. So literally hours. Newfoundland, Patrick harvested them, again, coolers, ice, and then fed, I believe it was FedEx, some courier, shipped over. Thank God Air Canada, was marginally involved, so we actually received the samples in a very timely way. And we want to make sure we acknowledge, is it Bounty Bay, Scott? Bounty Bay. Yes, we want to make sure we acknowledge because Scott actually took some of the harvested kelp that he had produced and actually drove it back home to PEI and dropped it off with you folks as well. So I would, maybe the Newfoundland was the longest, and that was maybe a day, because it was timed, the harvest and the transport was timed quite critically.
And as soon as we would receive the samples, we would package them up and freeze them right away.
Okay, I'm going to say lunchtime. Thank you to all of our speakers.
So, I realize many of you are sitting there going, damn, how come I wasn't invited to that November workshop? Lots of good stuff. That was an internal college partnership workshop, so we didn't make it available to everybody. This is kind of a, hey, let's tell everybody and our industry partners and so forth what's going on. And unfortunately, Canada's Smartest Kitchen, what an incredible setup they have there, very sophisticated equipment and so forth. And I think probably just by looking at the pictures, you could see a really fabulous array of products they presented to us. Many, they were all delicious. Unfortunately, with the access to the kitchen being limited here, a reduced amount of products coming, but maybe next year we can try to think of some way to get those folks, maybe hold something at the college where we get access to a kitchen. So that was an internal meeting just to sort of get ourselves all figured out and so forth, and that's why it wasn't made available to everyone. All right.
And just as I know lunch is happening now, but June is at the table where we have 3 samples that you can try before lunch, after lunch, during lunch, or whatnot. We've got some other samples for later in the day as well, but he's there and he can talk about them as you're interested and get there.
Awesome. I'm excited to try. I got to attend the event in November, and the food. I guess I'm a kelp lover because I thought it was all delicious. So yeah, thank you everyone, to the speakers this morning, to our guests online and who were able to come in person today. We're going to have some lunch now and be back online at 12:45 with Kate Collins from the Aquaculture Association of Nova Scotia. So enjoy lunch. Sorry to the people online.
So we're going to move into our afternoon session. So I think so far the discussions have been excellent. What I would ask for the people who are online, if a question is asked, we have a microphone that can go around the room. And if we don't use that microphone, perhaps if the question is asked to the speaker, excuse me, they can repeat the question so people online know what is going on. But it gives me great pleasure to introduce a former colleague of mine. Kate Collins worked at AGRG for several years, and many of the projects she worked on was with the Aquaculture Association. And now she's the Director of Projects and the Industry Liaison with the Aquaculture Association. And they're doing some exciting work related to kelp, so I thought it would be very useful for Kate to come and describe her project. So, Kate.
Thanks, Tim. Thanks for inviting me to come and talk today. It's great to see some familiar faces and some new faces in the room. So yeah, I'm going to talk about some of the projects that we're involved with at the Aquaculture Association and how they fit in with the research that we've heard about today. And I'll start with just telling you a little bit about the association. So we're the nonprofit industry association for sea farmers in Nova Scotia. Our main goals are to support and unify the efforts of industry to help expand aquaculture production. And so we're supporting our members through maybe we're coordinating research and development projects, helping members with their public engagement, their application process, and we're doing plenty of liaising with government at different levels. So we have different types of members: producer members, processor consultant members, research, academic members. Of our producers, we have 66, which is about half of our membership. Half of those are shellfish growers, and 3% of our members are growing seaweed. Our members represent 153 leases, marine leases in the province of Nova Scotia, which represents 95% of active aquaculture acreage in Nova Scotia. So before I get into more specific details about the projects that we're working on, I just want to zoom out a little bit. The research that we've heard about today is kind of bookending, I think, the sort of process, the sort of farm-to-plate process for kelp in Nova Scotia. So we're thinking about, the work at NSCC and College of the North Atlantic, when we're thinking about getting started with kelp farming, and then at Holland College and Canada's Smartest Kitchen, sort of the end of the whole process, the plate. So I just wanted to, I think where the aquaculture comes in is in the middle and making those connections, getting that research out to the farmers and potential farmers. So just to zoom a little bit on part of how that might look if you're thinking about becoming a seaweed farmer. So in Nova Scotia, it is a bit of a process. Since 2015, there have only been 36 new hectares of aquaculture area approved. There were new regulations that came out at that time, and it's a long application process to get a marine lease. You're essentially you're applying as though you were a salmon farmer or an oyster farmer. It's a long process to start a new lease from scratch. You can, if you're thinking about becoming a seaweed farmer and you're already farming some other type of species, it's much simpler to simply add kelp or a different type of seaweed or marine plant to your lease. But if you're starting from scratch and we're talking about growing the industry and making use of all the different research that's happening here today, it's a long process. And at the moment, there are no applications in the queue with the provincial government that are for seaweed leases alone. So there's nobody in Nova Scotia who's put their hand up and say, I'm the first one who wants to grow seaweed only I'm going to be a seaweed farmer and that's it. So we're not there yet. But I mentioned we have 153 member leases, and that's out of the 202 approved marine leases in the province. And 20 of those actually have seaweed on their lease already, so they're licensed to grow seaweed, and that includes sugar kelp. It also includes lots of other things. Sea lettuce and dulse are on some people's leases. But again, there's nobody who's growing only seaweed. So of those 20 leases that are approved to grow seaweed, only 3 are actually grown. So in Nova Scotia, we're very excited about seaweed, but at the moment there's just the 3 farms that we've been kind of talking about already this morning that are growing seaweed. But some good news. I feel like that's a bit of a Debbie Downer start to my talk. Sorry about that. But the provincial government is undertaking a regulatory review, so a review of those aquaculture guidelines that came out in 2015, and that should be wrapping up fairly soon. And we're really hopeful at the association that some of the results of those conversations will be a right sizing of the regulations for shellfish and marine plants in particular. So don't know what's going to happen. We'll all have to wait and see, but we're definitely hopeful that something like that will come out of it. Would be a big benefit to getting the seaweed sector going in the province. Having said all that, there's a huge amount of interest and potential for growing seaweed in Nova Scotia. So I'll talk about the challenges, opportunities, and progress. So we had the ANS in collaboration with the Ecology Action Centre hosted a workshop in October that I think many of you attended. And it was quite well attended, especially by industry, which was really good to see. So a really good turnout. We had some presentations from researchers and folks who are doing seaweed farming elsewhere in the world, and from ourselves and from the Ecology Action Centre. And in the afternoon, we did a SWOT type exercise. That was the workshop part of the day to develop a roadmap for sustainable seaweed sector development. So the rest of my talk will be kind of presenting some of those results, which I haven't shared back with the workshop participants yet. So thinking about that SWOT analysis in these 3 sort of buckets, I guess we could call them. The site selection and approval process, that's the first place you start for farming seaweed. Then we move into marine cultivation and processing and selling. So to me, those are the 3 big phases of growing seaweed in the province. So under the site selection and approval, we heard about some threats, and I mentioned some of them already. It was unanimously across the board, everybody who wrote down anything wrote down that the process for getting a lease in Nova Scotia is long and complex and risky, and the regulations, again, aren't right-sized. But, there was positive feedback that the government is engaging with industry. There's other countries we can use as a model. There were lots of comments around, because we're new, we can do this right from the start. We can all engage together and come up with some things now to start us off on the right foot. Lots of opportunities as well around using science. And so I think the progress that I wanted to report on, I think this is where the research that was talked about here this morning really fits in. If we think about the regulatory process, the site selection work and the mapping all fits together really nicely. Within the regulatory process in Nova Scotia, there's the scoping phase, review, and decision. And the scoping phase is where a proponent goes out and they have some time to find a site and study the site and figure out what's going on there, what are the conditions, and particularly if you want to grow kelp, how does the kelp grow? So it's great to see the mapping research that we heard about this morning, and I guess we'll hear more about this afternoon. And and I'm glad to be here today and to have these connections, because it's really important for us to be able to. And I think this is, again, where ANS comes in, is we can say to our members, here's what we learned, here's how you can access the science that's been done. Sometimes that link, it doesn't exist between what gets done at the science and research level and making sure that it's getting to the people that need to know it. So some really good progress there. In the first step of developing a sector for seaweed in Nova Scotia. In terms of marine cultivation, the ANS has been involved in some more things, and there's some good progress to report when we're thinking about marine cultivation. So of course you need some seeds, you need some kelp that you can deploy in the water and have it grow into long pieces of kelp that you can harvest. And so in the first research project that ANS was coordinating with Marinov and Dalhousie, the seeded lines needed to be created in Quebec. So that's a big barrier to having an industry all of our own in Nova Scotia. So as of December 2022, there are now 3 licenses for hatcheries in Nova Scotia. So that's excellent. There's 2 institutional and 1 with a private company. So that's one big barrier that I think we can say is, I don't want to use the word eliminated, that seems too strong, but it's definitely, we had a good kick at that barrier for sure. So in terms of the deployment and the harvest, there has been some good research happening there, again, with Marinov and Dalhousie, with Flora and Carly at the back there. And that project is wrapping up as of 2023, and it was really a project to say, can we grow seaweed in Nova Scotia? And it was with our 3 industry partners that I mentioned, and that Tim mentioned as well, Premium, Bounty Bay, and Cape Breton Bivalve. So they've been growing kelp on their leases in Cape Breton for a couple of years now, and had some good successes and good lessons learned about where is good and how deep is good and when we need to get out there and harvest, and some really good lessons learned that we can take forward to the rest of potential kelp farmers. Another strength in terms of harvest and deploying and the cultivation side of things is that we already have a workforce in Nova Scotia. People are trained to work. They may not know the specifics of kelp farming, but we're trained to work on boats and be safe and that sort of thing. There's still I think there's room for research in terms of inefficiencies in deployment and harvest, so lots of room to keep researching there, and a big opportunity to scale up. So I'll just share this slide really quickly. They're sort of pretend numbers, but I made this table for something different to show that we really are in a good position to scale up, and looking at things from this perspective kind of shows that, if you're just doing what we can learn from efficiencies in deployment mean we can have more lines on our lease, we can have a better yield per line, and then we can really increase the profit that a single farmer can have at their lease, and then we can add more leases across the province, and within a few years, I think we can look at a multi-million-dollar industry in Nova Scotia. So this, thinking about things this way can help us to focus in on those efficiencies that we need to really scale up from the pilot scale. We're really still at a research pilot scale in Nova Scotia and need some of these other pieces in order to be able to scale up, so that we can have kelp to cook up in PEI. And so the last bucket that I talked about is the processing and sales. So I'm just going to go ahead and read through all of these for you guys, if you don't mind. Just kidding. Not going to read any of them. This was the topic that everybody wanted to have a say in. This is clearly the biggest gap, I think, in Nova Scotia right now is, we've got the leases. Getting a lease is one thing, but if you've got an oyster lease already, say you can add sugar kelp to your lease. Now you can get your seeded lines, you can plant it, you can harvest it. Then what? So there's still a big gap there in how we kind of get the kelp quickly stabilized in order to, again, make some clam kelp. What was it called? Kelp matto juice. So I won't go through these really at all, but there's some really good data and kind of what the folks at the workshop in October told us about what they thought about the processing and sales side of things. So the way that ANS is involved with addressing those is a bit of good news. We're facilitating a project that has Acadian Sea Plants and Dalhousie as partners, and basically the project kind of picks up where the Cape Breton project leaves off. So in that project we are asking, can we grow kelp? In this project we're saying, what can we do with it? Can we dry it? Can we stabilize it? Can we sell it? So Acadian Sea Plants, the same 3 sea farmers are on board to grow some kelp, and so that kelp has been deployed and it's hopefully out there growing away in the nice warm ocean. And so the idea is we'll harvest that kelp in the spring, take it down to Yarmouth to Acadian Sea Plants, and they'll see if they can use their existing infrastructure to dry the kelp, and kind of research the best way to do that. And then they have a new piece of equipment that funding from Invest Nova Scotia helped to purchase. And so Acadian has that expertise on, determining the best way to upgrade the kelp in order to export it as a high value compound, or, to really look into those outside of Canada markets for something like sugar kelp. So we're really excited. If that is a success, if that research is a success, Acadian Sea Plants is willing to be a buyer of raw kelp in Nova Scotia. So if you're a sea farmer, you've got good, clean, high quality raw kelp and you can get it to Acadian Sea Plants quickly, they will providing everything goes well, they'll be a buyer of that kelp. So it's really takes, it kind of is another good kick at one of those barriers. If this can be successful in another year or year and a half, I think, hopefully, that we should have a sense of whether this will work or not. So really good progress. But that doesn't mean, there's not room for other ways to process and other facilities to process kelp in the province or other types of sea plants as well. And Dalhousie is involved with that project as well, looking at high-value bioactive compounds and concentrations, thinking about the 3 different leases that we have and the different environmental and oceanographic conditions in those leases and how the conditions there are impacting the quality of the kelp, and maybe different conditions make better face cream and other conditions make better dog food, those types of things. So we're all really excited about that project, so stay tuned. I also added here, I have a small project with IRAP, just working directly with Premium Seafoods in Ayrshire to see if any of the seafood processing facilities near their area are a good partner for them for processing. We know that some companies, especially other companies in the world, and one I talked to in Quebec, they use 2 different seafood processing facilities to process their kelp right away, and just for having the funding for IRAP to take the time to sort out those connections is a big, it'll be, I think, really helpful for our farmer in Cape Breton, and could be a good solution for other folks who want to grow kelp in the province. And then this is the stage, of course, where the Holland College research comes in, I think, and once we get that processing part figured out, then we've got the sales and the export that the work that Holland College is doing is really important. So basically, if we think back to that, those 3 arrows that I had at the beginning, I think we know all the things that need to happen in Nova Scotia, and I think there's lots of enthusiasm and encouragement. I think we're doing a great job identifying what needs to be done and slowly kind of taking a go at some of the big gaps, especially thanks to all the folks in this room. So thank you.
Time for a couple of questions, if any from the audience or online.
So you mentioned that there's 3 growers currently growing seaweed in Nova Scotia. Are they all local broodstock, or are any of these foreign species from outside of Nova Scotia, or where is it coming from?
It's local. It's all local. It's all very near their leases. Yeah.
And I believe Acadian Sea Plant's current model is to lay the kelp out on the runway and dry it first, is it? And then to grind it up? Is that still the mode they're thinking about?
That's one option. They plan to test a few different ways to dry it, because they have a few different dryers, because they work with rockweed and their version of Irish moss.
Okay.
So they dry those different ways. One of their methods of drying is the runway.
Yeah.
So that could be something that could work for kelp. Hopefully not. I don't think it'll be as successful, because kelp is it needs to be dealt with so quickly. We tried to harvest last spring using the runway method, and the logistics were too much. We need good weather for harvesting in Cape Breton, and then we need to get it down and have sunshine for at least 2 days in Yarmouth. And I was somewhere, oh my gosh, it didn't work. It actually didn't. We didn't get any. So technology will be better than sunshine.
Well, great. Thank you so much, Kate, for that update. Very informative, and keep up the good work. Okay, now I'd like to introduce Flora Salvo from Marinoff, and we heard a little bit about how she's teamed up with the Aquaculture Association, and I guess your talk is on here already.
So.
Press escape.
Still on the stick, right? Did I let you do that?
Lauren, did you copy it on here, or
Yep. Okay.
do you know where?
Sorry.
No. So there was that one
Yep.
and that one in your.
Oh, the one that's. How do I open? Is this one? Thank you. And I need full screen. Yes, I do. There you go. Thank you for inviting me for this workshop. It's really nice, and I'm sorry because I will repeat a lot what I have said at the October workshop because I can made up new projects kind of thing. But yeah, so what I will present today a little bit about what we do within Marinov in the seaweed sector. And so Marinov, what it is mainly a applied research center, and we are based in Quebec, and we affiliated with the community college of fisheries in Gaspé and Les Îles. So we kind of doing the in charge of the tech transfer technology and innovation from the college. And we have a tech access center too, so we're working also with CTAC to do some different projects. So mainly that's what Marinov do, and we're working in different sectors, mainly fishery, aquaculture, and bioprocessing. So there's different center of expertise working on fisheries, diversification of fisheries, mollusk cultivation, blah, blah, blah. There's a lot of different things. I'm going fast here. But today what I want to focus is why it's important to go towards seaweed farming and what are the projects that's going on in Quebec and in Nova Scotia at the moment, the one that I'm involved in at least. So Marinov works in all the aspects of the seaweed farming and products as well. We did a bunch of work like they did at that was presented before on trying to develop different kind of products with kelp and other species. So we over 120 projects in the seaweed sector between 2010 and 2020, looking at improving the technology for hatchery, for seaweed cultivation, for harvest, trying to transform the boat to be more efficient to do some harvest as well. And we're working also in extracting different kind of biomolecules from the seaweed. So why is it important to work on the seaweed sector? So there's two different sense of the seaweed sectors. Either you can harvest it directly from the wild population or you can farm it. And it's envisioned that the seaweed market will increase a lot by 2027, reaching up to $95 billion at the time. And it is why, mainly because people are more interested in eating seaweed and because it has a lot of nice properties and it's really nutritious, but also because it's the new vegetable of the sea and you can grow it without having any usage of soil, any fertilizer. If you grow it at sea, you just rely on the natural environment. You do nothing. So that's kind of really good. And more than that, there's different markets. So we were talking a lot about human consumption, but you can do a lot of things with seaweed. They can be made as fertilizer. You can add it to animal feed, and it's good for their guts. And you can extract different molecules and use it for the pharmaceutic industry or for the cosmetics. So it's a wide market. So that's why it's really interesting. And this market is segmented according to what kind of seaweed you have, what kind of application you want to do with, and what's available according to the seaweed you can grow or harvest, and by geography. Depending on the environment you are, you can grow this seaweed or this one. So I think it's really interesting that Nova Scotia and Atlantic Canada are into developing this sector, and what it is important to develop the seaweed farming at sea. And it's different land-based, that's most academic discipline is doing. And they're doing also some harvesting. So, but when you use farming, your site is accessible. You can do whatever you want in terms of husbandry on your site according to what's in your license, but you can have different skills or different, adapt your site for predation and things like that. You can access your site anytime, which is not the case when you have a harvest lease, where you just go there and you're not sure like what's going on with environmental condition, or if somebody comes and just lay there, like anybody can go there. So it's really important that, and more likely, when you do farming, you're not impacting directly the wild resource, you're adding some more resource in the water. So principally, to go back of what Kate was saying, there's the different steps of doing farming. So first you need to select a site. And what's important to do some mapping when you look at a site, you need to know what's the environment like and what can you grow? Is it a good site to grow the seaweed? Then you need to know what's the biomass there and what are the species, because it's really important for you to have the broodstock available to produce your seed. And also, what's another part that's really important for you, Liz, but also for you, is to know like how distant is it from a wharf? Is this space already used by other fisheries? What can I really use this site? Like, is it ice cover or things like that? So the importance of mapping is really there, and the work that's done through the program. The other part is the farming. So when you go through the license processing, you need this kind of first step of selecting the site. And then you need often to try some species. You don't go right away with full-scale farming. And you need to find the species that have a market value and that's have a reproduction cycle that is already known, because if not, you cannot produce your seeds. And then you can adapt your husbandry and try to develop new technology for seed supplies and et cetera, et cetera. And everything about processing, we talked about it before, that's everything is species dependent and on the end market you're trying to reach. So we're having also a project within Marinov in a collaboration with the College of Geomatic of Quebec. I'm trying to do the translation. And the same type of funding that brought us today. It's a smaller one. And the idea mainly is to do kind of the same work. It's to use the spectral characterization at low tide and see what are the abundance and the diversity of the species that we can find there. So the CGQ is in charge of doing the spectral imaging, and Marinov is in charge of doing the ground truthing. That says that's only done at low tide, so on the interdental area. And we did just one site last year, and I think there is a discussion to have with Tim as well for what's going on for next year, and if we can find a way of working together, because the funds were really cut off. And the main idea there was to try to have a better idea of where is the broodstock, where we could find species that we want to grow, but also that was asked for different wild harvesters that needed to know where is the biomass and where to apply for a new site for harvest. Now I wanted to introduce Innovalve. That's a new project. It's only based in Quebec for now. And the main idea is extracting the full value of Quebec macroalgae. So what had happened is mainly there is a big split in between the farmers or the wild harvesters and the processors, especially for high value end market. Like usually the farmers and the harvesters, they're doing human food consumption and like high-end products. But the processors, they were more like in Montreal and trying to extract high-value molecule from the seaweed, but they were importing it all, so without knowing what's going on the coast. So the main idea of this project is to develop and share knowledge on the potential for asset valuation, and bringing a bunch of scientific together is funded by the Fisheries Fund of Quebec, and bringing different partners that are processors, farmers, harvesters, and different and products. So again, the main idea was to try to characterize the biomass that's available in the coast, try to target species of interest for the different industry, and develop more sustainable ways to do molecular extraction and blah, blah, and make also a network and facilitate the work between the processors, the farmers, the harvesters, and the clients. So now, what about the project in Nova Scotia? So that's one of the sites of, I think it's Premium Seafood, where we're deploying the line last year. And so Kate talked about it a little bit already. The idea was to try sugar kelp in Cape Breton. So it was led by the INS, funded by the ACOA. We work with St. Anne University and Carly from DAL. And the main idea was for the three farmers, talked about them already, Bounty Bay, Louis Bois Seafood, and Premium Seafood, to do some trials. They wanted to diversify their market, and also because of climate change, there is more invasive species, and there is also the predation of the ducks that were impacting their profitability of their farm in Cape Breton. So they were all impacting the shellfish farming. So what we did is we deployed lines we produced the line and we deployed them at the three sites. So every quarter is a different site. We did that in 2020, 2022, and we were trying different depths, 2 and 4 meters. So the main goal was to try to reach to have a little bit like what was done around us in Gaspesia and in the US, between 5 and 15 kilogram per meter. And that's mainly what we achieve for the 2 year in 2 of the sites, the blue one and the green one. The other side, the orange yellow one, has different environmental conditions. There was more ice cover, and we realized that the husbandry and the calendar was not really good for the farming there. However, we have left some of the kelp for a longer time, and they were wishing a big size, so I think like just a question of management, and I think if adjusted, we'll have the growth. So the main idea is that's a big success. We're still working on analyzing the environmental data and the composition of the kelp to have a better idea of the difference between the site, but will be released shortly. So around this project, that's when I started with Marinov in 2020, and I was, with my background, I was like, well, it's really nice, we have an industry that's starting, but I mean, we have the problem of the seed supply, there is a problem of performance. We're in the context of climate change, like, will that really be working for a long time? So like, and then there was this thing that we needed to use local broodstock without having any science before that, and knowing like what the population look like. So that's working on that and discussing with NRC. We came up with a project where we wanted to look a little bit more into the population structure and connectivity of the sugar kelp to have the appropriate practices and embedded for farming and prevent the risk. So that's a partnership through the Ocean Grant from NRC. It's a collaborative project. That's Stephen O'Leary that's here. And the project aims to help the industry towards adaptation and climate change. We have also a postdoc student with UCAR and France Dufresne that will work on the population genetics and some implement from Genome Quebec as well. And we had a lot of support for sampling from Le Blanc Line, Kira Krumschultz from DFO, and ESC provided us from some sample when we had some issues. So the main idea of this project is to develop a sugar kelp seed bank and characterize the potential of some of those strains. So mainly is working on the population genetics, trying to map the different population and know a little bit better of how we can have different phenotype according to where we are. To create a seed bank and to try to select some different strain for different purposes, for conservation, or because they're resilient to climate change, or because they promote a better yield for farming, for instance. So even if this project is relatively academic, it's all going back to the aquaculture and the farming, is try to improve the practices. If we don't have to rely on the local broodstock, you decrease the number of tanks you need to do the hatchery, etc. To have a bank of seed, if something happens and your bed is not there, you can still have some seeds that are available to you to put in the water, so it's more sustainable for the industry. Because it's really hard to rely on the broodstock, but with the mapping that's done, it's really good to know where to go as well, and to improve the yield as well if we selected the strain. So for the population genetic works, we don't come from nowhere. Some studies were already done with France Dufresne in Quebec, where they studied 10 different locations within the Gulf, and it ended up showing that there was 3 main populations. So I'm just trying to go fast here. And the idea with this project is we will collect more sample from Nova Scotia and include also some from Maine, and trying to put it to use the same technology and try to see how that fits within what was done already in Quebec. But also, what we want to do is to try another sequencing technique. I'm not geneticist, so I want to answer a question about that, and try to use more informative markers with the same population and go deeper in the analysis and trying to refine those populations. What France showed, however, was the fact that the population in Quebec at least, had a really low diversity. So their recommendation was to maybe try to use local broodstock to try to preserve the local diversity and try to limit the exchanges. And the main idea as well will be to try to link the environment and the phenotype with the genetic understanding. So the main goal for that is to develop effective conservation strategy for wild population in Quebec, Nova Scotia, and development of sustainable practices for farming, at least of the sugar kelp. So I will show quickly what the sampling look like, and I will tell you why after. So the main idea is to collect data from the environment, so it can be local, can be old database, or like, a sensor you have there. And we collect 50 individual per site. We look at the phenotype, measure the different dimension of the kelp, take a sample for the genetic on the kelp, so we're following the individual, looking at the biochemistry, and then when they have individuals that are mature, we take them to put them in the seed bank, or try to develop this seed bank by individual. So, and the understanding of the relationship, the inter and intra-variability between the site and according to the phenotype and the genetic will help us as well to characterize what to put into a bank. And why I'm saying that, because we did some sampling in 2022. So we used 3 sites that's corresponding to the 3 population in Quebec. And we did 4 sites in Nova Scotia. But recently we were sent another site from Saint-Pierre-et-Miquelon. So I think it's really nice to have this wide coverage. However, if anybody knows where there is some kelp and want to help us to find new sites to target, I'm willing to take them, especially like we want to have a better understanding of Newfoundland or the North Coast, but like anywhere that's of interest. We were mostly selecting sites where farming will occur because it was a bit of the purpose of the work, but I think it's important with knowledge of the mapping, extra, to have a better characterization of what's going on. That's it. That was a request for more samples.
Okay. Thank you for that. Probably have time for one question.
That was clear. Yeah.
No, it was very, very informative, very good. I will just say we were part of the proposal with the. But unfortunately, they only got part of their funding as well, and somebody had to get caught, and it was us. So maybe we'll have a chance to work with those folks in another time, but thank you so much for that. Okay. Now we're going to have a presentation virtually. These are from our colleagues at the College of the North Atlantic. Blair Bridger is going to present, and his colleague Darren Brooks is also working on the project, but we're going to hear from Blair today, and he's going to give a bit of an overview on sort of the 3D mapping side of College of the North Atlantic, and hopefully show. There's Blair, good to see you. I hope you're feeling okay and up for this, so I'll let you take it away, Blair.
Sure thing. So can everybody hear me okay?
Yes.
Okay, perfect. So I'm just going to share my screen really quickly. Okay, so here we go. I am a little bit about me first before I get going. I'm one of the primary geomatics instructors at the College of North Atlantic, located in St. John's, Newfoundland, and I've also done a fair amount of work with the Office of Applied Research and Innovation over the last few years. And as Tim pointed out, it's both myself and my colleague Darren Brooks that has been working on this project. My focus is on the mapping side with the drone that I'm going to give a little bit of overview about today. And Darren is working on the predictive mapping side with the GIS part of the project. So I'm going to focus on the mapping part of it. My presentation won't be overly long. We were supposed to be able to do some simultaneous mapping with NSCC last summer, but unfortunately our sensor never showed up in time. So we never got to do that mapping, but we're hoping to do some mapping with them this summer. So to jump right into this is essentially the system that we've acquired that we're going to be using along with NSCC's plane-mounted topobathy system. So this was a new acquire for the Office of Applied Research and Innovation as part of an insert grant that we applied for, I think about 2 years ago now. So this system is a UAV-mounted topobathymetric LiDAR system, right? So the whole idea of us acquiring this type of unit, the main focus was transition areas from land to water. So it's meant to be a shallow water mapping system, and it's really ideal for mapping, small rivers, streams, and shallow waterways to really highlight transitions from land to water. Its real claim to fame, and I'll talk a little bit about that when I get into the specifications, is point density. A lot of these topobathy systems, even if they have a lot of depth penetration, you don't get a lot of points per square meter. So this system, although it's meant for shallow mapping, has a really, really high point density. So at the altitude you'll be flying this system at, you're looking anywhere from 100 to 200 points per square meter. So our focus when we do some mapping with NSCC is to verify kelp density versus what they're getting with their plane mounted system. So the system usually gets depth anywhere from 1 to 5 meters, depending on the clarity of the water, right? So this is kind of an overview of what you'd expect to get from this system. Again, they really push for point density versus depth. So from that image you can see there on the right of your screen, I'm guessing you've got the topobatrics side of things. You're doing land-based. Depending on your altitude, you're getting anywhere from 50 to 100 points per square meter. And then in your bathymetric, anywhere from 100 to 200 points per square meter. So this system will really able you to identify and highlight structures within the water column. So we're hoping it'll be a fantastic tool for mapping kelp, because it usually doesn't grow in deep waters, and even if it is in a bit of a deep water, the kelp itself grows up fairly high. So what we're seeing on the right there is, I guess, the negative side to this system, and that's its depth penetration. So the visible part of this, obviously the more turbid your water is, the shallower the system is going to go. But anywhere from that 1 meter down to 5 to 6 meters if you've got really, really clear water. So we're hoping that when we do some collaborative mapping with NSCC in Newfoundland, that we're going to get some really good days and get some clear water and really see what this system can do. So a bit of an overview of the Astrolite itself. It's a high definition 2-in-1 LiDAR for topographic and underwater mapping. And again, that was their focus, was the high definition part. The system is very small. So we've recently just acquired our system, and it mounts easily on our M600 DJI platform. So I'm going to show you some images of that. So that was the really draw for us from the Office of Applied Research for this unit was, it's light, and you can mount it on a UAV. So it's very easy to employ in different areas. So the LiDAR's performance in shallow water, it's really, really, really good. Like that's their focus, was shallow water mapping and high density. It has sub-centimeter accuracy and precision, so focusing on structure identification in the water column. The green wavelength, so the bathymetric part of this LiDAR, it does have a SOCI depth of 1.5, right? So it's not as, doesn't have a high depth penetration as say the airborne one that NSCC has, or some other systems like the Regal system, but it does have really, really high point density. So the scan pattern for this gives a near constant point density. So it has a 30-degree scan angle, and it maps out a swath about half your flight altitude. So usually when you're doing bathymetric mapping, you'll fly about 20 meters above the water. So your swath will be about a half of that flight altitude. So if you can fly lower, the better, but usually you're looking at anywhere from 15 to 20 meter altitude when you're flying for bathymetric mapping. So again, combined with the scanner and the LiDAR performance, the point clouds you get from this are typical densities of 100 to 300 points per square meter with the centimeter level resolution. Now, unfortunately, I don't have any data on our system, but towards the end of the presentation, I'll show you a video that Astrolite, or the Lightwave, actually shows for some of the data you can collect with the system. So those are just some system specs. I won't read everything on here. Just highlight a couple of the important things. The weight of the system, obviously, it's a light system. so it can go on a heavy-duty UAV. It's, again, the accuracy and precision is really good. You're looking at about a centimeter in your accuracy and a half centimeter in your precision. Your laser beam footprint, so you got 33 centimeter footprint of your laser beam at a 30-meter altitude. So again, we're going to aim to fly anywhere from 15 to 20 meters. And your point density is really the thing that we're looking forward to on this system. So just to give a bit of an update from the last, meeting that we had in PEI with Holland College and NSCC, we had yet to receive our system yet. So we finally did get the Astrolite system on January 5th of this year. And we've been waiting almost a year to get this system. So with the backlogs and everything else, it took a long time for us to get it, but we finally do have it. Training was provided by Lightwave on January 16th. So I've been trained up on the processing side of the system. I've had our unit mounted on our M600, so I'm going to show you some pictures of that. And we're also getting a custom camera mount developed by a local company, MakeTech Aerospace. So we've collaborated with this company a couple times. So they're making a custom mount that we can put a Zenmuse X5 camera on the M600 along with the topo bathymetry sensor. So we can do aerial photogrammetry and the aerial and the topometric and bathymetric LiDAR simultaneously. And that'll allow us to do some planned flights as well, rather than just having to manually fly the flight lines. So that'll allow us to do a lot better line spacing and control the pattern that we're flying a lot better. We do have some testing we're hoping to do with that system before the summer. We've got a local company that's interested in us testing out the use of the system on some shallow water ponds locally around St. John's area. They're doing some interesting work with eel habitats. And one thing that they're missing is accurate bathymetry data of the areas where the eels are living. So we're hoping, if weather works out for us, that we'll do some test mapping projects with them over the winter, that we can get some data sets to play with before we do some kelp mapping in summer. And that's the last takeaway on this slide, is that the system will be up and running and available to do some mapping with NSC this summer when it comes to Newfoundland. So this is just an example slide of some of the point cloud data and some of the things that are highlighted from the system when we collect the data. Again, their main focus isn't depth, it isn't mapping deep water, but is really highlighting transition zones from land to water and being able to identify structures within the water column, including vegetation. So from this slide, you can see this data set was done in Florida. So obviously the water was really clear and it was a shallow waterway they did, but it highlights the seamless transitions from the land to the water. And it really points out that you can see structures within the water column really easily because of the point density of this system. And the little video I'm going to show is going to highlight that as well. So this is the custom camera mount that we're getting developed. We've already had one like this developed for our M600 with our aerial LiDAR platform. So we've got another setup for that drone specifically for terrestrial LiDAR, not bathymetric LiDAR. The same company made a custom mount for the camera for us as well. And they're essentially doing the same thing for the Astrolite system. So once they get that mocked up, we're going to put it on the M600 and make sure it works with the sensor platform. And again, that will allow us to do the photogrammetry and the terrestrial and bathymetric LiDAR simultaneously, and allow us to do flight planning, which is a big bonus. So you're not manually flying the drone for your flight lines. You can do a lot more pre-planning. And this is the setup that we have right now. Again, as soon as I got our system, I test mounted it on our M600. So this is a few pictures of the system mounted on our drone. And it's very light, it's very simple to use. It's self-contained, so it doesn't really connect to the drone other than just to lift it and carry it. You turn the system on, it does its calibrations, and when all the lights are green to go, you just fly the drone and it does everything internally. Once you land, you take the data off on a USB stick and then you go through your processing routines. But it's a very simple system to use. and it's just push and go. Most of the work is on the back end when you actually start getting into processing the data and aligning GPS with your point clouds and doing the IMU stuff on the back end. But the unit itself is easy to install, it's easy to deploy, and it's very quick. So I'm just going to stop sharing this screen here, and I'm going to share their website. Second. Okay, so I'm going to hope everybody can see this. And this is not a very long video. I just want to show this just to give everybody who hasn't seen this system before an idea of the type of data that you can collect with it. So again, this is some test projects it did in Florida. The water there obviously is a lot clearer than we see in Newfoundland, but we're hoping to get some good weather days and some good clear water when we do some flights for the kelp. So this is, again, showing the shallow water where they did and then showing some of the objects that you can see in the point cloud when they process it. And this is some of the neat data that you can get from it. So let me pause this on and off as we go through. But just with the point density you can get with this system, you can really, really highlight structures underneath that water column. And that's really what we're hoping to be able to do when we do some of the kelp mapping is really highlight the kelp bed and show the density of that kelp underneath the water surface. And when you go through the processing of the point cloud, it's really neat how they separate the surface of the water from underneath. So even though this video here is showing both the water and the bathymetry, you can take the two apart and take the water off and just show the bathymetry underneath. So if there's anything in there you're really trying to highlight or any structures, you can take it out. So I'll pause it here again just to kind of show when they did this, they threw a box down there just to show the point density. So this is a 1 by 1 meter box they had in there. And you can just see how many points show up on that as they fly over it. And again, that's the real cool thing about this system that we're really excited about testing it on is that density that you can really highlight structures in the water column and get a really clear image of what's down there when you fly the system over it. So the point of this is they're also showing, again, with that point density and the terrestrial and the bathymetry side of this, they are even be able to point out that little solid light structure that was there. It was really small, like there wasn't very much a surface on that, and they're still able to point that out. And again, that seamless transition from land to water. Right, so again, that's an 8-foot float that's showing up there, and you can see the light pole there as well. So again, with the density of this system, you can see some really, really small things once you map with it. So I'm really excited to see how well this can actually map the kelp, and that you can use that to get really, really good kelp density from it. So I'll just pause that there, and I'll jump back to my presentation. Okay, so that's it for me in terms of an overview of that system. Does anybody have any questions?
Thank you, Blair.
Hi, did you see anything about the scan pattern that it uses when it's collecting data?
You mean how the system, the pattern of the LiDAR when it's scanning?
Yeah.
I thought that was on this right here. They have a linear cross-track scan pattern, and your scan angle is plus or minus 15 degrees either side. Does that answer your question?
Yep.
Blair, I have a question.
Sure.
I know the system is very new. Do you know how many systems they've sold, and are they able to share with you who have the systems elsewhere? Just thinking about talking to other clients, seeing how other people are making out with it, what they're using it for, things like that.
I don't have that information right now. I have reached out to them, Tim, to ask those types of questions. I was hoping to have some of that for today, but they haven't gotten back to me yet. But that is something I'm exploring with them to get some idea of where this has been used, just so we can get some of that information as well.
Okay, okay, great. I mean, with that kind of point density, the volume of data is going to be quite significant, isn't it?
Oh, yes, yeah.
Yeah. No, I can't wait to see the system in action, and fingers crossed that it can deliver what we're hoping it can. I mean, it's quite
Fingers crossed,
exciting.
absolutely.
Certainly the only one I'm aware of in the short term. I'm actually going in a couple of weeks to the LiDAR mapping forum in Denver, so I'll be keeping my eye out. I'm sure those folks will be exhibiting there.
I'm sure they will.
Yes.
Are you looking for Kelp farms to partner with to scan?
The question was, are you looking for a kelp scientist to partner with? Was that a kelp farm to partner with? Yes.
Oh yeah, we're always looking for anybody who wants to help us out here, and we've got the system. We're looking for ways to employ it. So absolutely, if anybody's interested, you can reach out to myself, and I can get you in touch with some people within the Office of Research and Innovation. And we're always excited to work with different partners.
Maybe this afternoon when we're discussing the plans forward, that topic can come up again. We'll have to look, we got to figure the budget out to get Blair over here to Nova Scotia, but I think to fly one of the firms would make a lot of sense with the
Absolutely, yeah.
Okay. Well, Blair, thank you very much. I appreciate you doing this, especially knowing you're just hopefully on the recovery from COVID. So really appreciate you doing this remotely. And I guess you're going to stick around and this afternoon come back in when we talk about future plans.
Sure thing, not a problem. Glad to be here.
Okay. Thanks, Blair. Take care. Okay, next I would like to introduce Kevin McGuigan, who works at the Applied Geomatics Research Group. Kevin is a research specialist and has been with the group for probably 12 years or so. Not enough to get like this, but Kevin is a fantastic researcher and does a lot of our data processing on the LiDAR and has developed several automation techniques and so forth, and always has some fantastic visuals.
Okay, I'm going to blast through this as fast as I can. Sorry about the mic there. Yeah, Tim's mentioned me a couple times and kind of said I'd elaborate and explain some things, so those piled up pretty quick, but we'll see how quickly I can try to explain some things, or at least show some of the more gritty detail of what we've been working on. So just a quick outline here. I'm going to kind of go over our basic data products, dive into more of the kelp mapping techniques that we've been using so far to kind of give a preview of that on two different scales, so kind of interesting there, and then dip into some various madly off in all directions style future research that we're always doing at the AGRG. So I like to start with this just to show that, LiDAR in a typical sense is, the industry comes from topographic LiDAR, so underwater is kind of a newer, more fringe thing for LiDAR, but on land, we're very highly qualified in making very high quality survey grade data, and, we should especially take advantage of this in this region because we're lucky to have the whole province flown in this type of detail. So I think that, we see a lot of rasters of LiDAR, but just know that, the actual point clouds themselves are absolutely beautiful data sets. And we at the AGRG are like I say, we've been doing this we're kind of pioneers in this field actually. So we're kind of the first group to be involved in surveying LiDAR in Nova Scotia. And we've been involved in instrumental in kind of these wide area mapping projects where that's where we get our elevation data now for the province. And one of the kind of miraculous things about traditional topo LiDAR is we can see through the forest canopy to the forest floor, and that allows us to do cool things like map the tree heights, right? So in Nova Scotia, New Brunswick, PEI, we have all the tree heights, and it's absolutely underutilized data. But so we're spilling this over from a well-established industry into the near shore now with this bathymetric data. So we as AGRG are very much applied research in the sense that we're connected very intricately with the companies that do this type of work. So typically what we're most applied to do, I guess, would be performing the task that they perform, which is operating the aircraft, performing the survey, and having high quality data as rapidly as possible to be delivered in a standard format, right? So we've kind of got that backbone, and then a lot of these Kelp style mapping projects are kind of, like I say, built on top of that. And yeah, just to mention that, like, a lot of the work we do comes down to this, like the surveying type of techniques involving positioning and of the aircraft and all that type of stuff, which is really shockingly accurate. I don't know if that's going to autoplay, but just moving into the bathymetric world, think about that previous point cloud we showed of the land. It gets a lot hairier, a lot quicker, very quickly in the bathymetric world, especially if you get greedy with your surveys, where you're like, hey, we've got the plane, we've got it for 3 weeks, let's go fly half of Newfoundland today and see what happens. There's a good chance, we've all been experienced the coast, the conditions can change rapidly, and these sensors are essentially operating in the same way that our eyes operate, meaning that, by that I mean, like, if you can't see it, then it's also struggling not to see it, right? So it's in the optical range, these bathymetric sensors. So cloudy water is bad news for these scanners. And operationally, it's hard for us to know before we go to northern Newfoundland, is it going to be clear that day? Well, we're there, and we find out it wasn't. So a big part of my job comes down to sometimes juicing what we can out of those type of surveys, because the value is still there. It's just harder now to get the information out of it. I guess there's my autoplay version. So yeah, we put a ton of effort into automated classifications, because that's really the drive of the industry. It's very, very costly and expensive to manually clean these data, have someone interpret them. So it's all about these pre-canned geometric style processors that can identify the seafloor and that type of data routinely. And those are, we've kind of got a Heinz ketchup style secret sauce of that at this point, which is always getting more and more challenged by new tricky data sets that we collect. And another aspect that's always a little bit challenging is we have an asymmetric scan kind of pattern, right? We're not getting, when we fly over, we're not getting the same sampling from every location. Our particular sensor scans in an elliptical pattern, which is really good in some sense, but it does create a bias of, we're basically 10 times higher sample rate on the edge of that scan. So it's like you see more, but then to make a cohesive map, you almost have to throw that piece that you saw more in a different orientation away. It's a challenge for making these nice cohesive data sets. And I just want to mention that we work with the developers of the system to actually try to do the best we can here, and we've had really honestly great success. So that's been great for us, and in the bathymetric industry, kind of the standard product is just the elevations, right? But we've done quite well there, so we've kind of moved more into the reflectance, which we've seen some of that work, which is just another order slightly more challenging to get that nice cohesive product. And then also some of these derivatives, like the map, the eelgrass mapping. so eelgrass and kelp mapping. So just to and this is way overkill from the talk Tim gave earlier, but just to reiterate, these standard products that we expect to get right out of the aircraft, even the same day that we fly sometimes, we would have the elevation model, and these are actually floating point rasters, if that means anything to anyone, that are referenced in meters. So this has a meter height and we use a terrestrial survey standard for where that height is, but you can move that to any local benchmark you want, tide, different things. We can also look at maybe the depth during the survey, which might be useful for different aspects. Typically, you'd see that type of data shown with a hill shade, so it can show the kind of detail, which Tim did a lot of earlier today. And I mentioned this LiDAR intensity or reflectance. So this is the actual backscatter volume, the brightness that the laser returned at. And we put quite a bit of effort into kind of normalizing that, and this is a work in progress. So you see these get blurry and have weird artifacts show up. It's quite a disgusting code base that tries to get this stuff to work, so there's all kinds of bugs and things to work on there. And we also, obviously, we collect these beautiful air photos at the same time. And as Tim said, again, they're very, very susceptible to bad conditions if it's specifically in terms of the water surface. So we'll talk about that quickly. And just to mention that we do get a near-infrared camera as well. I got to speed up here. I can feel the pressure. And this got a little bit ambitious here with this little zoom in. Whoa! Okay, so let's jump from, that's kind of our standard operating AGRG day-to-day thing. Like somebody might call us and say, hey, can you survey half of Florida? And we'd be like, I guess so. That'll take 4 months. Let us know, and I guess we can. But then we might get another call that's like, hey, can you survey the kelp in Nova Scotia here and there? Like, I guess we can do that too. So here we are doing that, and we like to show the COC for this because it's probably the best study site to start in. And what I'm going to demonstrate here is just kind of the standard, most reliable technique that we have now for teasing out the what's going on in the data to correlate. To correlate to what we're observing with this ground control data. So we use a basic machine learning approach called support vector machine. And we don't have to talk about that. But basically, what we can do from this level is if we can get good, reliable inputs, like we've shown, our photography data, our elevations, a nice intensity model. This is a quite nice one here. We'll typically do we'll decorrelate those to each other to highlight just the value, the areas where those values vary, and then we will kind of inspect that, and then we can also investigate a lot of these kind of derivative metrics. So, looking at the elevation, we can compute the aspect, so what direction that's sloping in, which has a very strong biological indicator. Being the sun typically to the south here. We can look at the local roughness in various ways. So here we're looking at kind of the average versus the height at a spot over different sizes. So this can kind of highlight the areas that poke out of the elevation model. And again, we can generate these more and more features that kind of generate different aspects of the texture. Here we're looking at just the kind of the variance of the elevation in a certain area and the variance of the brightness. So these are all kind of things we can just kind of come up with cool ideas, read the research, find out what's working in other parts of the world and other similar techniques. And again, decorrelate all that data, put it all together, look at it all at once, and then just kind of add that back in with the other data set. These are some kind of data dimensionality reduction techniques to get those all down into just 3 dimensions so we can look at it at once. We can then cluster that to say, hey, if I say that there's 5 different things here, where can you kind of best fit that data, this singular 3-band data, into 5 clusters? And am I starting to see features that I'm interested in right now? So that's a good kind of first thing to do. And then basically there's kind of a nice workflow there once the data's been prepared that way. If it's all nice, clean data, where if anyone's ever used the remove background tool in PowerPoint, it's essentially the same thing, where you can iteratively go in and say, this is sand, that's kelp, this is sand, that's kelp, and kind of have this feedback loop of watching that result converge on that boundary that you're interested in. And it's a little more sophisticated in principle than the PowerPoint tool, but it's functionally very similar. And that we use, like I say, a support vector machine technique. So this is where our ground validation and breaking things down to the species gets tempting to be like, hey, how far can I go with this? And we like to push the boundaries and what we can do. And I don't want to suggest that these species and distributions are correct at this stage of the game, but just to show that this technique is kind of well established, and it produces visually results that are quite captivating, but I think this needs the eye of someone who's more familiar with the environment and significantly more ground control data to really kind of get a better sense of how accurate this is. But they produce quite beautiful results. And sorry for this plot, I wasn't able to fix this one, but this black line, this disgusting black line, is actually the Biosonics plant height estimation. So again, we have more data that we can feed into these models, and in this sense, it's being used as a validation to show, okay, our sand and our kelp bands are at least in sensible locations. Now, that is that's a very achievable workflow. It's very well supported in the science, in the research. A lot of the bands that I put into there come from kind of good practices that you see from similar work being done elsewhere. But I'm pretty interested in the non-machine learning techniques as well. I like to try to I basically just play around with the data a lot, and so one of the things that kind of amazes me, and it's just kind of in the history of remote sensing, there's this beautiful equation called a normalizing differencing ratio. So I'm going to kind of step out of the bay. If you have any questions, this is kind of like the final results we might expect with a slightly different distribution when it's well validated for different kelp species in a given bay if the data is good. These results are readily achievable with a little bit of effort. But if we're going to pull back and not have someone look at every stitch of the region, and we've kind of had this other way of mapping these things for a long time that's more into the magical category than it is into the data mining category, which is approaching on classical science of coming up with an equation where you can define things. But again, like I say, there's this beautiful equation called a normalizing differencing ratio, which was developed by a mathematician to improve early Landsat satellite observations for seasonal variability, so they could do consistent plant health observations. And they've created this famous metric called NDVI, everyone's probably heard of, which is based around that. But it turns out to be a really just awesome equation in and of itself. And we can use it in our use case to auto-normalize pretty robustly against the surface variation of a photo. So that's kind of cool. And what I'm showing right here is a red, green, blue image, and it k-means clustered it's on the right, k-means clustered. And here you're starting to see something that's really neat about the human brain. Your brain sees what's on the seafloor there, but the computer clusters the water surface. Because the actual, you have an optical illusion happening where you can't see the fact that this wall is wildly different brightness as it goes away from that light to that wall. But the computer doesn't think of the world that way. There's all kinds of hidden processes that allow you to do that. So one quick way to reorganize the data so that you can see the seafloor and remove that water surface variation is this normalizing differencing ratio technique. That's really quite cool. And what's really exciting about that is we have now massive, well-organized data sets of satellite data. So if we can come up with these systematic ways of normalizing things we're not interested in, like the sea surface and other attributes, we can apply these techniques to do basic math, like take an average over long time periods of large satellite data sets to come up with techniques for basically observing underwater, which is, I think, very exciting. It's one of the research one of the facets of research going on now that I personally try to stay very up to date in, which is what they call satellite-derived bathymetry. So there's a lot of ways to do this type of work, but I'm particularly interested in these kind of straight-shot formulaic ways, as opposed to machine learning or very complicated optical ways. So again, using this this normalizing differencing approach in a very particular way, we're able to normalize out these kind of aberrations of the satellite being observed scene by scene and across different conditions with the water over long time periods, and then come up with an average observed underwater brightness, which is so powerful. So we have the whole Earth visible in this type of technique, and it's just a direct calculation from a large data set. There's no cloud masking here. There's no, like, typically you would remove the images that had clouds. That didn't happen here. It's done with a ridiculous implementation of this normalizing differencing technique. So this is kind of two branches coming together here. We're trying to map the shallow seas from satellite, but we're not really getting the depth. If we're interested in this satellite-derived bathymetry, we're seeing the depth plus the bottom color, right? So, we're so close. But as it turns out, there's a really kind of nice correlation between different radiometry and the effective depth. Maybe I do. We'll see. So we got really close to deriving satellite-derived bathymetry from satellite. What if we just compare that really close value to actual bathymetry, right? So we actually have a massive amount of bathymetry for this region collected by CHS, a lot of it with topo bathymetric LiDAR, actually, in these larger campaigns. And this is a freely available data set called the NONA data set, which basically means don't use this to steer a boat, because they didn't take the same amount of attention to detail to it. They typically do it with their charting. But we can, and I'm sorry for how pathetic this unveiling is, but basically we can come up with the difference, the remainder between what the optics say is depth and what the satellite, what the LiDAR survey said was depth, to come up with what you could really call a shallow dark thing map, right? So this is a 10-meter resolution shallow dark thing map with a time span of 2016 to 2022 for the whole region, which is awesome, right? I wouldn't go as far as to really say it's submerged vegetation, because there's a number of things that can make a dark a bottom appear dark, but it's really quite captivating. And so what I would call this whole piece would be the kind of the wide area coarse mapping technology. We kind of have the medium technology with our airborne LiDAR. and we saw kind of a high resolution version as well. But it's really nice to compare these resolutions, right? Because there's really only one thing happening at a place. So if we look across kind of what we're familiar with, you know, we can kind of see with our eye. This technique is, it's got some discontinuities, but it's at least highlighting the areas where, you know, we're seeing sand versus something dark, essentially. So there's a lot more work to be done here, and I wouldn't, like I say, this isn't a go there and harvest kelp map. This is a really kind of early part of the research, but I get excited when I get to scale things up. So the fact that this is, you know, as global as wherever we have bathymetry data to base this off of is very exciting. And just to show that does, again, you know, we've seen this, but in a similar sense, you can see that this relationship, which is satellite derived from existing bathymetry, maps quite well to the data that we're collecting in all senses. Now, where it doesn't map correctly is where it gets deeper. So these relationships are kind of being, you can project them in different ways. It's kind of up to you how you linearly best fit these to each other. So that's where I think the next steps Tim will talk about. You know, we got to go deeper. We got to collect more validation data a little bit deeper, just to be sure what we're looking at, and to get that linear relationship down. So again, we're looking at that same area now. The red box is the hawk essentially, and we can pull out and look at kind of the whole region. And you were talking about where can you find kelp? This is where you can find shallow dark things. Maybe it's kelp. So it might be a good place to look. You know, just so anyone who's interested, this is based around Google Earth Engine is an aspect of how this is done easily, which allows you access to these large time series of satellite data very conveniently for applying mathematical functions to them. So it's really quite amazing time to be doing this stuff. So that's kind of turning from how we kind of morphed from how we typically operate to kind of some of the research, but now let's go like further into some of the research that we're constantly doing. So this has been a kind of a thorn in our side for a long time. Is, you know, there's techniques for removing the glint. So I just want to mention that as something that we're always trying different techniques, and there's a lot of different research and papers about this stuff. But we're looking for the real slam dunk way of just, you know, removing glint entirely, so we can eliminate that as an issue for our models. But so we you know, just to mention that we have some techniques there. Another thing that's kind of been one of our white whales is, and the work from that higher resolution drone will really help with this stuff, is coming up with point classifiers that work directly on the vegetation itself. So we're challenged with that because our point densities is a little bit on, like it's just on the edge of being able to routinely map the vegetation. So I think having these higher res systems to help direct that work will be great. And we've had instances like this where it's worked so well that we're like, oh, we can do it. But it's kind of a conditions-based system where this was a perfect day where we just were able to write an automated routine that these are plant heights based on the point cloud classification. So it was so perfect. We were like, we did it. And then we did it the next day, and we didn't do it. So, yeah. And just to reiterate that, you know, it's quite a challenge to get these things to operate friendly and routinely. And they can get quite disgusting. So to the point that, you know, we have a number of students, we distribute this data to all of them, and then we say, go look at the kelp and map the kelp manually, and they're like, they come back, it's like, what? So it's like, it's hard to tell what you're looking at. There is, I kind of put these in order, but just one more thing I'd like to mention that we've been playing with recently that, maybe I'll jump to this one first. There's always been, in the back of all this, there's a full waveform version of the LiDAR. So we're very interested in that, where it's actually collecting the readings along the depth profile, not just these points. Right? A point is a downstream process of these waveforms, but there's no industry real push to improve this technology. So it really comes down to me and a couple other crazy Swedish people that are like, it would be really cool, and to actually take our evenings and weekends to put this together into a waveform-based system. But there's just to be aware, there's a ridiculous amount more information and detail that's exploitable from that. So stay tuned for that. But in the meantime, right now we're all probably in the room aware of how neural nets are just infecting everything and taking over how everything works. And one very, very exploding field right now keep thinking I spelled that wrong, is what's called a neural field. So that's the idea of, instead of having a neural algorithm that works generally, it works very specifically to the data you're looking at, and essentially it works as an interpolator. So you can go from having discrete points, which is a real pain to classify, to having a volumetric field that all data is represented equally, and it's there's no holes anymore. So we're early days in playing around with this, but we're very excited about the idea to potentially extract like a continuous biomass or a continuous plant height and all these types of things. But this is literally all the figures I have about this. So that's just coming through. Truly black arts, that stuff. And another thing that we're very interested in, but which we haven't had much success in yet, is underwater photogrammetry, which some people have had great success with. So actually building a photorealistic rendering of the underwater environment using cameras. But it's a real challenge because everything's kind of moving underwater, and photogrammetry relies on coincident views of the same object. And if everything's moving, it kind of falls apart. So we're that's something in the back of our minds. And I think that's basically everything. But I just threw this in there just to show that I mentioned to my uncle about kelp mapping in Newfoundland, and he's like, "Oh, you should see after a storm these giant 6-foot mounds of kelp everywhere in Newfoundland." And I was like, "Okay, well that's interesting." And so what having all this data available to us now, there's a satellite constellation called Rapid Eye that from Planet Labs that actually does almost a daily image of the Earth, and so we can look at pre and post Fiona and see these rack lines in Newfoundland. It's in Port aux Basques, Newfoundland, and yeah, sometimes your crazy uncle, he's right, and so what the species are in these things, but kind of interesting as a crossover there, because we're also interested in flood mapping, and this stuff is something we're going to be definitely pursuing, but there's probably a environmental monitoring aspect to seeing where these things emerge and making some kind of inference of what's going on nearby and stuff like that. So I just thought that was relevant and interesting. But I guess that's this is a big this is a lot of time and a lot of things coming together to try to present something as a story, and I think it's really exciting for me to talk to people about this, because I'm kind of a map it first, ask questions later kind of person, and it's pretty cool to see how some of this stuff can actually make an impact. So like I can see how some of these layers could be relevant to various people that are actually knowledgeable and interested in what's going on. But yeah, and honestly, it's an exciting time to be dealing with this type of stuff where everything's coming together. Is that half an hour? I don't know. Is it?
No, perfect.
Yeah. That's a stretch. Is there any questions? Yep.
Any questions for Kevin? Come on, don't be shy. On one of those slides.
Yeah. But I just like to say that as a community, I think it's really important that we make these data available and then make it so people can reference it and say where it's right and wrong, because it looks cool, but it doesn't mean anything until someone's like, nope, and then that would create the feedback loop to make it actually say something that's true as opposed to say something that feels true. So I think that's an important point on this, but yeah.
No, great. I'm sure you perhaps can appreciate why I wanted to make sure Kevin spoke today, because he really is a fantastic researcher in our group to stay on top of the latest remote sensing literature, push the boundaries. I mean, when he first started talking about Google Earth Engine, I was like, yeah, whatever, but he's brought me around, and he does a fabulous job as a great mentor to some of the younger research associates in the team as well. So we're almost at our break, but I believe, did you guys at Canada's Smartest Kitchen, did you folks want to speak any more about the snacks that are out? Because I know there's more additional snacks.
Yeah, Arisha can introduce them so that people are ready for their coffee break for sure.
So on top of the other samples that we had earlier today, Yes, so we have chocolate truffles as well as kelp puffs. And in the bags of the puffs, you will find a little sachet of seasoning. So you can either have the puffs by themselves, or you can open up the little sachet and put a little bit of spice in there, shake it up, and you're good to go. So yeah, hope you sell.
Great.
We have a lot today, so yeah.
And I had on my first slide an acknowledgement to Springboard Atlantic, and I want to just make sure I thank them again. They were the ones who have helped sponsor this workshop for us and covered the venue and the lunch and the breaks and so forth. So we'll thank them again at the end, but just want to express our gratitude to them for sponsoring this. And please enjoy some of those and beautiful kelp snacks. And we'll reconvene. I think we're maybe running a little bit, but we've left a little time at the end here in the discussion so that if we did go over a bit, we were still good. So 2:30? Yeah, so we'll reconvene at 2:30. Thank you. Okay, I'd like to get the last sessions of the day started, please. So we're going to rearrange the order of presentations slightly. Arisha is going to give the Holland College Canada's Smartest Kitchen overview of the future and what directions may take place next year. And also, I think query you on what your thoughts were and get any feedback on the delicious kelp snacks they brought. So.
Thank you, Tim. Yes, so like Tim mentioned, I would like to know what you guys thought about all the samples that you tasted today, because all the data that every single time we've presented these samples, we like to collect the data from that to just kind of have a better idea of what the general perception is about kelp products. Like, basically, what you've tasted, tell me what you thought. If you liked it, you didn't like it, please. If you didn't like it, tell me why you didn't like it, because that would really help us. Yeah, so any thoughts, comments, anything about them?
I can start with, I mean, those puffs you make are, you know, to me, they're ready for the market right now. They're very tasty. And the little chocolate ball, yeah, I was chatting and I think we both have the same opinion that, you know, when you first bite it, it's a bit like, oh, it's got something else in it. But then it kind of grows on you.
Yeah, it's actually...
And that's all I had a chance to try.
Okay. Anyone else?
Both of the drinks are fantastic.
Yes.
The tomato and
Yeah.
both.
One of the interesting pieces with the not clamato juice, but that beverage was Alex was able to formulate using kelp a vegan Worcester sauce for it. So she's kind of got that layer in there as well, which kind of opens up that door of like ingredient supply and stuff like that as well. So it was quite interesting. That's why we wanted to bring that one too. We were going to do a Worcester tasting, but we thought truffles would be better.
Oh. The slides? Yeah.
Do you have it?
Do you know where?
I just want the last slide on.
I wasn't here.
Does anybody in the room think that there's a friendly angle to any of the snacks that you tried today? Like, do you think people who have kids, their kids would try them or be nervous of them or anything like that?
My son, I think I mentioned to you, really likes beef jerky. I think he's probably alone in that. He's 14. He's 14. But since he was maybe 10, he really likes beef jerky, and I know he would like that smoky application to something. Yeah.
Okay.
But I think he'd go for any of the desserts.
I think the kelp sesame bars come out kind of like Rice Krispie treats, like tasting.
Yeah.
I think my kids would eat that, thinking it's like a Rice Krispie treat. Yeah.
Want me to take one home and try it? What do you have extra? I'll give it to my ticket.
Make the puffs into, dinosaur shapes.
That's right. That's what I think too. Yeah, kids love chips, and as long as you don't tell them anything new to them.
I think the cracker will be good for the kids.
Yeah.
Looks like chips.
Yeah.
One question I had about the kelp that you have back here in the little containers.
Yeah.
So my husband bought this big jar of kelp, like powder or whatever. And then I was taking it, put it in my smoothie, and he's like, "You're only supposed to use an eighth of a teaspoon." I'm like, "Oh no!" So why is so little? Do you think?
That would relate to one of the questions that we had earlier about the amount of cadmium, I believe it was, and iodine in it. So you don't want to overdo it because iodine toxicity is a thing, and you have to be careful with that.
Thankfully,
yeah.
The second time, but I was like, more is better, right? No. I was like, it should have a little shaker instead of being in this big bottle. And then a little scoopy.
Like a salt replacer, for example, right? Okay, so now that we've talked about how great these products are, what would you guys say were something that you tasted and you're like, ooh, maybe not for me? or if there was any negative feedback.
I wasn't waiting for my phone to be done, and I think I needed to be prepared. Like, it's good, but I already had made a mess.
Okay.
So not a taste issue, but a texture.
Yeah, and this is not a taste issue either. I thought the chocolate and truffle was good, but I smelled it first, and the smell of kelp kind of put me off a bit. And then when I ate it, I was like, okay, it tastes good, but it definitely has a pretty strong smell of kelp, I think.
Well, the truffles actually only have the digitata powder on the outside, which is why, like, the first whiff you get is like, whoa, kelp.
Okay.
Yeah, this is why. Yeah. Yeah.
Going back to children and what they would like, you also have to think about parents, especially moms, so maybe dads too. I noticed also that one of the Rice Krispie type one crumbled a lot, and that would have driven me crazy when my kids were little. I used to make my son eat cookies outside because it was like you would literally know, even at a birthday party, that's where Ethan's at. So you got to think about the moms as well as the kids or the dads.
But it's important feedback because for a product developer, this makes us think about portion size, extrusion size, all the cut sizes, those kinds of things. Because if that sesame snack could be single bite,
right.
Maybe it's 4 in the package instead of 1 larger one.
Right.
That kind of idea. So we're always taking this kind of feedback and getting back to the kitchen to wonder.
Yeah. Well, thank you everyone for being adventurous with us and trying new kelp products. So moving on, the work that we would like to do at CSK is going to, first of all, delve more into product development. And the idea with that is to take some of the formulations that we thought had potential but didn't quite work out, like the digitata meringue, for example. That's something that we're hoping to continue on the work with that. But also, like I mentioned before, we have agarum and alaria, which are 2 fairly tough kelp samples to work with. But the plan for year 2 is to figure out a way that we can include them not only in powdered form, but find a way to use them treated, so dried and rehydrated, for example, or pickled form. Like as soon as you harvest them, then you find a way to process them right away, just to kind of retain some of the fresh qualities of the kelp. It doesn't necessarily have to get dried right away and then powderized. That seemed to have worked the best out of all the samples and all the treatments that we've done so far, but we would like to explore other venues with using the kelp. Yeah?
Sorry, can I ask a question?
Mm-hmm.
Speaking of other venues for the kelp, is anyone considering replacing the plastic packaging with so much going on with biodegradable packaging being a CD? Is there any interest in that?
I remember at the last workshop that we had in Halifax, the October one, we talked to a student from UPI that is looking into using kelp in packaging. I'm not sure, I don't know anything about kelp and packaging, but I do believe there is work out there being done on it.
Seems like something that should be included in this initiative. You're going to be handing out
Yeah.
so much plastic.
I delved into my own food experiment this summer. After visiting the folks in Arashat, they were kind enough to give us some additional seafood. So I cut the kelp, the sugar kelp, into strips and boiled it like fettuccine noodles.
Mm-hmm.
And first I was just totally thrilled with how green and really cool it looked. I think you could get kids hooked on it just from that. And then, it really tasted good. I hope I didn't overdo my iodine intake. I have no idea. But have you guys done that? I don't recall seeing anything like that. Or maybe it's too raw, too simple.
Well, we have done that as one of the ways to process the kelp, but with sugar kelp and digitata, we found that the blanching for a little bit worked. Agarum and alaria, it does not help with the texture at all. We did end up, the samples that you see over there were actually boiled for 2 hours, and then freeze dried. But even boiled, freeze dried, and then powderized, it's still, if you look at like some of the bigger chunks of the alaria, for example, it's still fairly tough. Like you wouldn't want to chew on it, for example. Like it would hurt your gums.
Yeah.
Yeah, we've tried it. I mean, at least I have.
The digitata, I appreciate. I tried it later with that, and I never could get to the point that it was nice to chew. But the sugar kelp, I thought.
And I think that's one of the reasons why sugar kelp is in so many products on the market right now, because it's just so much easier to work with, and there's just a lot of, I guess.
Does it make more sense considering that I assume sugar kelp would be the dominant kelp to grow? Like there's probably nobody planning to grow digitata.
People are trying.
Yeah?
Yeah, like right now, at least in Quebec, there's alaria that's grown, and products, and sugar kelp.
But there is potentially, we talked to people in Iceland who are working on using digitata to create a bioplastic that absorbs water. And the example that they used of what it could be used with is diapers. So in terms of replacing plastics, it would be like a very big game changer.
And every seaweed has its own properties. That's more targeting for like food or extracting biomolecule or things like that. So.
And
it depends on the end product you want for your farm.
Yeah, and some of the other examples we've seen of people doing the bioplastics, they've been having problems with the fact that they can make them, but they're not good with anything wet. So basically food products aren't there yet, but they can like wrap a $200 Gucci t-shirt in bioplastic.
What's the price of making right now? What's the price of making this
but there
sustainable
are, there are people working on it, and then, the sugar kelp seems to be a lot easier to grow right now than the digitata, but people are trying to farm it.
Speaking about the iodine and the other possible heavy metals, but maybe specifically the iodine, is there any processes that could be used to reduce those compounds, not compounds, but elements or nutrients you don't want in there, to lower more readily consumable levels?
I would go down the extraction pathway. So if you have a method to extract specific minerals out of your mix, then whatever that's left over, you would still be able to use it, but it all depends on the extraction method. What you're adding to the mix, if it's something like a solvent that cannot be edible, then you would have to throw it out. But it would all depend on whatever extraction methods you're hoping to go. But there is a way to get it out. It's just what you do with whatever that's left over, that's, to be explored.
Kind of bring back the days like when I was a kid and you cut yourself. You had it out of the wimpy mature chrome. You didn't really do anything when you had the iodine. And Mom hit you with that. You felt it. And hey, you cut the same thing
there. And so with all the information that we're hoping to collect, the idea with developing all these formulations is to, at the end of the day, be able to have industrialized formulations to be able to offer to food companies anywhere that's interested in using kelp, in maybe even working with the farmers, trying to figure out a way to process it directly from collection in a way that they can have an end product as a food to be put on the market. But our role at CSK is to develop different formulations and figure out a way to industrialize those formulations and have it ready for food companies to further the work with using kelp. And all that information that we will be collecting will be ready for sharing with everybody. So, I believe that is it from CSK. Do you guys have any other questions?
I can't wait for next year's results. Okay, great, thanks.
Thank you.
I've only got a couple of slides here. So I just have a few slides about next steps. Okay, thank you. So for us, there's not a lot planned at this stage of the game, but we are interested in feedback. Oh boy, that's quite washed out. My apologies. Based on our chats with Dr. Patrick Gagnon at MUN, he also has some study sites on the West Coast, and I believe the environment is quite different, and therefore the kelp is, I'm not sure about different species, but definitely different situation on there. So we have there's no way we're going to survey that ellipse, that's for sure. But we are going to, our mission is to go to the West Coast. We may add something around St. John's, depending on how we collaborate with Blair and his drone. If he can't get to the West Coast or the timing and things don't work, we may do a survey around St. John's, and in which case, maybe Bay Bulls might be the closest place to go. But, from our perspective, it's a heck of a lot cheaper you see the little tip of Nova Scotia there, it's a lot cheaper to bring the aircraft from Nova Scotia to the West Coast than to ferry all the way over to St. John's. So we've got that up in the air still. We do have some flexibility, but right now that's our plan for Newfoundland, with that possible caveat of working with College of the North Atlantic to collaborate on a flight. So any of our colleagues in Newfoundland, feel free to reach out to us about possibilities. There's a group around Gabaroos who is quite interested in promoting this idea of multi-trophic aquaculture, where maybe you've got shellfish growing and you've got kelp growing and things like that. So we thought we might do a survey somewhere up around that area in eastern Cape Breton. The exact details we haven't really figured out yet. And that's currently, the only plan. So I've heard a couple of interesting things already at the workshop that, did you say, Lauren, somebody told you there was a lot of alaria around Digby Gut and Briar Island? So that's kind of interesting. Whether we fly the LiDAR there or just take our boat and do some drops and video tows would be interesting. And I'm sorry, I forgot your name. Melinda showed me a really fascinating photograph. And Melinda, was it sort of on this shore or was it on?
No, it was, right
Okay.
from the air shot.
Right there, of a garum that grows there, yeah. So that was kind of interesting. So I'm not 100% sure I want to commit to doing a survey right there, but maybe. Again, at the very least, if we have to if we're going to go up here to do ground truthing, it would be interesting to do a couple of transects here with the boat. We've been to Canso before, and we know how tricky it is there. But that was quite interesting to see that, and news to me. So that's currently our thinking. I think we learned a lesson on the first round that more is not better, contrary to kelp consumption ideas, and that we've are still kind of struggling with the data, the volume of data we've got, and now we're at a stage where we really want to focus in on some areas and look at some of the things that Kevin was expanding on. So to go in year 2 and fly huge tracts of the coast, I don't think is really something we want to do. And we used a fair chunk of budget in the first year with all that jumping around and our usual aircraft provider changed, so we had to bring a plane from Ontario, yada yada. But so that's currently our plan, and of course, we still have a lot of data we need to continue to work through. As Kevin showed you at the Hawk, we have the raster-based classification to try to come up with where is the kelp distribution, not really an estimate of biomass. I think we want to rely more on the point cloud to try to see if we can make some sort of estimates there. But we would like to do that for every one of our study areas. So we still have a fair bit of processing and work to do in the lab to do that. But certainly in the summer, we will want to go out and collect more data. We'll certainly do a better job, I think, this year of trying to avoid the glint, because the photos are very useful to us. We've also realized that down in this particular area, at the very least, we probably want to expound our ground truthing out into the deeper water a little bit. Because once we got out past where we had ground truthed, we're not exactly sure what the vegetation is out there. I'm assuming it's kelp, but the only way you're really sure is to actually put some eyes on it ourselves. So that's one area we'll follow up, and you never know, by the time summer comes, we'll have all these other maps processed, and may expand our ground truthing efforts to go and revisit some of those sites. So I look to my colleagues at DFO there. Any thoughts on a wish list or on a within reason? Kevin.
The room that, looking at the shallow dark things map of the area, Stonehurst seemed like a really interesting geography that blew like a light bulb compared to everywhere else. And looking at it just from a photo point of view, like there's a lot of interesting things in the water. That's directly east of Lunenburg, kind of on where Lunenburg you continue on to the ocean, and unbelievably challenging looking place for boating, because it's a ton of islands, but it might be interesting. And I'm more and more not for your survey, but for the larger community involved to be like knowledgeable about that area, but it did have significantly more noticeable signal than just about anywhere else in terms of shallow dark. Could be geological in nature, but vegetation. It's kind of a very highly folded igneous area, and it there's a lot of rocky plants.
Certainly, to go and hit a spot like that, especially if we have a target. We did these surveys really without specific targets in mind. So it was always a struggle between making the polygon perhaps too large initially, and Nathan kind of going, whoa, do you realize how long that will take me to fly? And then scaling back so that we got good synoptic coverage, but yet not have him have to fly 3 days in the same place, because the weather conditions don't hold here for 3 days typically. Once in a blue moon maybe, but and therefore then all of a sudden you've got, half my survey was done, and then 2 weeks later we were able to come back and finish it, and that just, it's better to get as much as you can in the one flight. We deviate from that sometimes, but it's much better to try to get as much in the single flight as possible. So to go to a target area, we don't need to fly as much. And now, when you talk to people about LiDAR, we're always hesitant to give a cost on a square kilometer basis, because then people will give you this very convoluted polygon, and we then have to say, well, you realize we're in a fixed wing aircraft, and therefore we have to fly straight. So the cheapest polygon to fly is a rectangle. And what you want to do is avoid turns as much as possible, because every time you turn, you're burning fuel and costing money, and you're not surveying. So a short little square isn't really a good survey either. So we want to fly in rectangular survey blocks, but maybe not like the Eastern Shore Islands area, which was a fairly big one. So feel free to contact us between now and the spring if you have any ideas, or somebody's told you there's an incredible amount of kelp, or some sort of kelp diversity, or anything like that, and we're flexible and open to those ideas. Yes.
Yeah, I'm just wondering, because feels like there's an awful lot of data, specifically looking at the maps that Kevin was talking about earlier. And one of the things that we've used for eelgrass monitoring is citizen science, which is to throw it out on a map, but like all around the province along the shore, there are people who walk every day, who kayak, who do all of that stuff. And while it might not be as detailed, but just that confirmation that, like, yes, there is eelgrass here, as seen in this Google Maps data, might be a really interesting way to get a much broader coverage to add into this layer, along with this data, with the drone data, with the Google Maps data, to kind of, you know, optimize our citizens.
Yeah, no, I mean, when we were out on the Eastern Shore Islands, I mean, there were tons of people kayaking for sure. So I think that that definitely would play a part. And I think it would probably go good with the scale of his, you know, shallow dark things idea. Whereas our work, you know, we're eventually going to be dropping those points over top to see, you know, did we classify it correctly? And that's why we're a little bit uptight about the quality of the survey points we take. They can't be within 5 meters. They want to be within, you know, 10 centimeters. So when we're comparing apples to apples, we're actually dropping the point down where it occurred in the proximity. So I do think there's a lot of value in citizen science, and we can gain a lot of knowledge from that, and then use it at the appropriate scale where we're not worried about the precision of the measurement. Any comments from people in my group, you know? Go ahead.
I have a question, not for Nova Scotia, but for Newfoundland.
Yeah.
So we're targeting the northern part of the coast, I guess, just because that's where Pat is doing some work, is it? Okay.
Yes. I don't know exactly where on the West Coast, but I know he has a West Coast site.
The southern part of the shore, where all the finfish aquaculture farm are, there is also a need for environmental monitoring to look for the kelp bed when they apply for a license for finfish farming, like online. So it could be interesting for the industry to have an idea of what's going on there.
I'd love a reason to go visit Port aux Basques and see what's going on there after Fiona. So when you said the so shore, do you mean Port aux Basques area?
Like, right from here, from Burgo to up to Fortune Bay.
Okay. Well, maybe we can follow up and have you know, draw something on Google Maps or something, and I'll certainly chat with Pat about it when they're not on strike. Our original plan, you know, you make these grandiose plans in the office, and then, you know, when you do get to the field, you realize, oh God, that's virtually impossible. You know, we were wanting to do the West Coast flight, but we only went to Newfoundland for about 8 days. And to do the ground truthing we did, there was no way we could, you know, and we actually had some vision of doing something in the north as well. So we had to scale things back quite a bit from just a logistics point of view to be able to collect the ground truth. So I suspect, you know, that will be enough of a challenge to get over, but I am keen to do as much as we can around different parts of Newfoundland. And hopefully he's able to participate. As he's got the right vessel, he's got the gear and everything, so it was a very complimentary relationship. Okay, well, again, hopefully you have our contact information, so if anything comes into your mind in the future, feel free to contact us. Can we have Blair back on? I think I'm a little ahead. Hopefully he's... Hi, Blair. I don't know, do you have any slides talking about what your folks' plans are, or do you want to just have a discussion?
I don't have any slides.
Okay.
So we can just have a chat about it. Like, I'm not sure what Darren's progress is on his predictive mapping side of things, so I can't really speak to that end. And in terms of the mapping, we're just kind of on board to work with NSCC come up in the summer. Whatever areas you want to fly to map, we will work with you to get the drone to those locations, right? That's the That's the good thing about having a drone. That's easily movable. We can go wherever you need us to map. So that's not a problem. But the interesting thing, if there are a lot of other places in Newfoundland that have kelp that need to be mapped, that's a good thing with the drone as well. Like if you can't get the plane to go anywhere, we could explore taking the drone and doing exploratory mapping projects. That way would be a cheaper way to see what we can see.
Okay, so I guess the idea of going to the West Coast is not that big a deal. You guys could
Not at
accomplish
all.
that.
No.
All right, very good, very good. Well, that will sort of be our working plan this summer, and then the additional idea might be to try to get Blair here in Nova Scotia. So those 3 farms are still growing sugar kelp. 2 farms, okay. Okay, and I assume the plan will be to harvest again in early June? Okay, so we would need to try to coordinate that before June. I mean, that might be, see, it's a little tough for us, because once we bring the plane in, then we need to have a certain amount of work available to make it all happen, or to make it worthwhile. We can't bring the plane in for one survey and then send them back and then bring them again. We just don't have that kind of budget. But to maybe get the drone over here in June, and then we do a comparison of the airborne system and the drone over in Newfoundland, would still be some really valuable science to have and data to look at. So maybe that's a working.
That's something we could definitely look into. Yeah.
Yeah, that's a working hypothesis we could have. Is Darren on the line? Do you know whether he wants to speak at all, or what his plans are? Do you see him in the list there, Darren Brooks?
I'm not sure if he is or not.
Okay. He would be Blair's colleague, and he works out of Corner Brook. Is that right?
Yes, he's one of the instructors for the post-diploma GIS program. So that's out in Corner Brook. Yeah.
Okay. All right. So that's a loose plan there as far as maybe get the drone, fly one of the farms before they get harvested. Plan for the West Coast, Nova Scotia. We've got a couple of things on the back burner we may fly. Kevin, anything else? Anything else we should be thinking about? Google Earth Engine everywhere.
3 kilometers sand spit off EI. I'd love to survey with that. There's no shortage of interesting looking photos on it.
Yeah. Kate, is there have you sensed any feedback from your membership about any particular areas? For example, Charlene, I know Charlene LeBlanc, I believe, down in Southwest Nova, she's very keen to get into this, and I know I don't know where her leases are, but we'd be interested to hear from any of your members if they had a burning desire for a particular area or something like that. Because we are committed to trying to help that whole initiative, and to map the wild brood stock, I think, is the main contribution this technology can make in that regard.
We're having our AGM next week, and I was thinking of giving a bit of an update on this big project.
Okay.
So I can ask if there's anybody who made a survey.
Is that going to be virtually available as well? Okay. I think I'll get an invite to that. I assume I get all the letters, and I think my dues are paid up. I did get an invite. Yeah, I know about it.
I know like a couple of sites around Pimlico with a sugar kelp, because she helped us to do some sampling this year.
Yes.
She will be interested in that.
We actually did fly a couple of strips that we did not include in this, loosely around Pubnico, but we actually had some technical issues with the sensor at the time, so we didn't include that data, and we got things fixed up and going again. Okay, well, there's a bit of sunshine out there, so I don't want to keep you in this room if our discussions are done. But please, if anybody has any comment, question, or anything, Kevin.
We have a follow-up, so if part of sharing data, really didn't, you don't have a strong comment to make now, but is it an opportunity for discussion of what people would expect or what people would intend, but maybe that's a longer, down the road.
No, that's a good point. I mean, you know, for us to push, for example, all those point clouds up to the internet, the volume is pretty incredible. The raster products, no problem. And I think maybe what we could do is shove up some samples of point cloud data of where we have some ground truth, so that if people wanted to look at the data and explore it, at least they have some ground truth of that area to say, oh yes, this is what the bottom looked like, this is where there was kelp, and so forth. My boss is no longer here. It's too bad. I was going to give a little jab at the IT people. We need to get those IT people to free up some, drop the firewall a bit, so allow people to access the data. Otherwise, you know, I guess we could pay for some cloud service, but that doesn't seem really good use of money.
Some data, also summary data on the CIOS.
CIOS? Yeah, I mean, we could use a third-party group. Yeah. Yeah, does AceNet host data? I don't know. Well, we will continue to explore that, but please, any ideas you have, feel free, and I mean, I'm open to explore them, because I suspect whenever you come up against an IT, no, you can't do that, you know, you're basically fighting up a steep hill, and I've got enough of those to fight anyway, so. Okay, well, I'm going to wrap things up. So first, I want to thank Springboard again as being our event sponsor. I'd like to thank all the speakers today, Canada's Smartest Kitchen, College of the North Atlantic, Kate and Flora for their presentations, of course, Kevin for mine, Nikki for organizing all of this. We'd like to thank the folks from Atlantic Live Stream. That's did a great job, and that's a great name. It makes me think of salmon or something. Like, but really appreciate that. I'm sure it was a much better experience, and the fact that it was recorded rather than us trying to fumble our way through Teams. So thank you very much. Of course, we want to thank NSERC for funding the whole project and the initiative. We want to thank our online guests and all the questions that have come from the folks online and in the room. Especially thank you in the room. It's nice to present to real people in a live environment after a couple of years of not having that situation. The Cambridge Suite staff, of course, and the team from AGRG who have, behind the scenes done a lot of work putting this together. Thomas generated a lot of the figures that I used, and many other people have been involved in the project. So, last chance for any last comments. Yes, Nikki.
One last comment. We're going to be sending out a survey with just a few questions to get a little bit additional feedback. So keep your eyes open for that in the next day or two.
Very good. Very good. Well, again, thank you very much, everyone. And we're available to have interactions with, and any suggestions, ideas, we're always open to those. And thank you very much. And those that have driven, safe travels, and stay tuned for year 2 of the project.